about free energy and anti-gravity. And that's when I got hooked on it. Started researching it and building these devices. I even wrote a book. Everything that, well, almost everything that I have is posted on academia.edu.
Which book did you write?
What's that?
What's the name of the book?
Newtonian torsion physics. So it's a big, thick book. It's written more like a scientific paper.
Textbook.
And it covers, esoteric topics in the field. For example, I examined the Biot-Savart law, which was developed back in the 1830s. And I discovered that in that law, it has special relativity built into it. So I was rather surprised to discover that.
All right, William, this is all very good stuff. I want you to save it for when more people are on, because right me and you, and we started a little early here, but we definitely want you on. Oh, here, Tim Ventura just joined.
Hey, Tim. No audio yet.
Why don't you just eat your dinner and shut up?
Okay, Tim Ventura is going to be our host, and I just made him the host. He's going to be the moderator for the thing, because I'm going to be in the lab over here just doing work and stuff, and pretty much just a show and tell and a nice chill, and grab a beer or a cigarette or whatever.
Hey, Bill, long time, man.
Hey, Tim.
Eating dinner, huh?
Tim and I go back a ways.
Yeah. Where are you living? You're not in Sedona still, are you? Or are you?
No, I'm down here in Scottsdale.
Oh, okay, okay.
Northeast side, right?
Nice and warm then.
Oh yeah. Well, we have 2 seasons here in Phoenix: summer and nice.
Yeah.
It's nice.
Are you with that lady still?
Yes, that lady. Yeah, she's
'cause
right behind me here, Aurora.
Yeah, sorry, I forgot her name. It's been a while.
Tim, I just need to make sure a couple things before we start. Are you very familiar with Zoom and like how to shut people up and all that, and spotlight certain screens? Okay, because I gave you over the reins for the conversation, so you can pinpoint, whoever needs to talk, and whatever, interject whenever it's going off the rails, and crazy flat earthers get involved or something like that.
Yeah.
We want to keep it scientific and engineerable.
So you've got, let me see. You have a fellow with the demo, right? I think Jeremy. Did Jeremy have a demo? Jeremy had something new this week.
Yeah, Jeremy has a demo. Wayne might have a demo. I might have a demo. I don't know. It's really just the conversation that's important. He has a ton of demos, just scattered around his lab, and as we're talking, he'll probably like pull one out, and when he's ready, he'll give you the buzz. Say, hey, I'm ready for this. I'm thinking of should I send out another email with the link again? 5 minutes.
Oh, I'll reply to everybody. There, I just said we're on now if you want to join. So.
Oh yeah, just include the link in your latest email. I'll copy the link up so everyone gets updated.
Yeah, because these are older fellows, so.
Yeah, they want to see the click.
Yep.
Old stuff?
I didn't get my power supply up and running yet. I think it's the switch that I found the other day. So I have some leads and stuff I'm going to try to hook up and see what happens when power as it's powered up, what the voltage across the switch is, and whether it's a faulty switch or not. It should be easy to change it out.
Okay.
I hope I didn't set like expectations too high. One thing I wanted to talk about, I don't know if how in detail we should get, but we should definitely mention that everyone's getting together here at the lab in December for the whole month of December. Me and Jeremiah and possibly Jeremy are going to be down here. We're going to be working on all different experiments. So we're keen to hear what is, you know, possible in that kind of time frame on a low budget, and we can try a whole bunch of experiments if anyone has any ideas.
They're all on now. Tim Turner's on, Bill's on, the other guy's on, getting on. You better get on and use yourself. You're so shortly.
You want me to introduce Hunter?
See if you can get him. I don't know what. Let's see if there's anything there for you. So I asked Mark today if he's getting any movement going, and he said, not really.
Mark?
Oh.
Yeah.
You talking about me?
Oh, another Mark.
There's lots of groups.
Anything about some amp for metal? He said did he get that done? Did he get that accomplished? Okay. Oh, who, Skylar? The metal people? Or the weird people? No, yeah. All right. It's encouraging to know that I'm not talking to this semi-full-fledged idiot for nothing.
Yeah.
I'm gonna grab some beers.
Be invited to Alzafon Hills.
Well, so Bill Mark is working on, he's working on this Alzafon, I believe it is. That's what's motivating him, is the Alzafon.
Experiment?
Yeah, that's kind of what his driver is. So, and basically, if I remember right, he's looking at, it's basically like nuclear quantum resonance.
Why?
Nuclear resonance.
Yeah, where you align the particles to the electrons. I don't remember which. I don't remember if it's the protons and neutrons to the electrons, but you basically align those, and then send them into precession. So it's like an NMR kind of a thing.
Uh-huh.
Oh, okay. Well, Dan, or somebody comes across the finish line. Uh-huh.
So I guess we'll see what ends up happening here. I don't know.
Is he, I assume he's going to demo something, or?
Yeah, I think so.
Okay. At the moment, I'm working on over Unity technology
You
here.
lost me there for a second. Yeah, they can't hear me talk.
Bill, did you see that article about the two transistor system where they were able to convert Brownian motion into?
Yeah, I'd like to know.
No, I didn't.
Okay, hang on. Let me find that for you. You could build that. That would be a Bill thing. That would absolutely be a Bill thing.
We're only talking about technology that can be engineered. All right, so that's a focus. So listen, I don't know why Bill's contributing. I don't know. I'm not sure. But he says it's creating this camaraderie with one side of it's in Bill. But, you know. Anyway, we should just get this mouth shut. Unless they're an investor. Unless they're an investor. Why is he talking to him? Yeah. I wish Bill would shut up.
Why?
You don't broadcast your adventure until it's over with and you're at the finish line.
I'm not there yet.
Yeah, you should be quiet.
Okay.
Unless you're talking to an investor, why don't you shut up?
No, you gotta see if this stuff is gonna work. You don't know yet.
Dennis, if you go on there and say that and ruin our chances of them getting any investors, I will kill you.
I'm not saying
Okay.
that at all.
Steph, I will literally kill you.
I'm not saying any of that.
Well, there, shut up.
See, come on.
Bill, you get the biggest mouth in the history of anyone who's supposed to be on the down low.
Not me, Libby.
He's
Hang
just
on.
down low.
There.
Shut up. Bill, shut up.
There we go.
Anyway,
We've got some other folks. Paul, thank you for joining. There's Wayne.
You're welcome.
James.
I might go over there. Whichever you going over. Yeah, it's kind of it's a nice walk around. Yeah, I've been going there every year for. Huh? All cards.
I'm going to mute everybody out and then just type or wave your hands or something if you don't want to be muted. Does that sound okay, Mark? We're starting to get a crowd.
Yeah, that's a good idea. I think there's a way on Zoom to like raise your hand. Is there? I guess just raise your hand.
Yeah, there you go. Oh, there's James.
Hey, Paul. And James, Wayne.
Oh, but okay, yeah, he's there. He muted himself. I couldn't unmute him. Do you want me to mute myself? I can mute myself.
Oh, no, don't mute yourself. You could do the introduction. I'll introduce what we're doing over here.
Well, you're going to have to explain it, right? I can introduce you. You know, this is Mark Sokol. He's been working on Alzafon's experiment, right? That's a fair.
That's fair. I mean, we're trying a lot of different things. Basically, I started this group. It started off as just a WhatsApp group where I found similar people who are interested in anti-gravity research and that were actually trying real experiments. That was my caveat. Actual engineers that were trying this on like a shoestring budget. And we got them all into a WhatsApp group together. And it's an international team. Wayne is from Canada. We have Nam Tran from Vietnam, who puts together some pretty cool stuff. Jeremiah is from Milwaukee. He'll be joining us in a bit. And he's an amazing engineer. And just having everyone in the same chat box, which is pretty much live. Everyone's getting live updates about different experiments that are going on. We found that to be a very inspirational and useful way of sharing the technology and learning from each other and learning from each other's mistakes in order to try all different experiments related to anti-gravity. Whatever, but by anti-gravity, I basically mean how those flying saucers work, how the Tic Tac flew 90-degree turns, 10,000 miles an hour. So there's a couple different theories that cover it. And right now I'm working on Alzafon. Wayne is also working on it in a much more rudimentary fashion. We have seen some results, but it wasn't really that much above the noise floor in order to get too excited about and publish anything. And I think one of the reasons why we didn't get such good results is because we were only using 20 watts of microwave power. Basically, the Alzafon experiment, I'll give you a little overview for those who aren't familiar. It's based on this paper by Frederick E. Alzafon, Anti-Gravity with Present Technology. It was published in 1981. And he goes into a unified field theory of basically gravity. He sees it more of an electromagnetic function. And one thing that he realized is that on a fundamental level, the gravitic field is coming from the nucleus. It's not coming from the electrons. And one characteristic of the nucleus is chaos. All the protons and neutrons, they're all spinning in different orientations, and there's a lot of randomness. You know, second law of thermodynamics, everything gets broken down, more entropy. So he theorized it's possible to disconnect yourself from the inertial frame by making a coherent state, making all the matter in the core of the atom spin coherently. It's another term for this is dynamic nuclear orientation, which is a very obscure, scientific research. It's similar to NMR and much more closely related to EPR. Basically, you have a laminar or homogeneous magnetic field, which brings about the electron orientation spins. And the electrons are spinning at the speed of light around the atom, and you're not going to be able to interact with them much at that speed, but they do have a Larmor precession, similar to the way the Earth's precession spins around every 25,900 years, the precession of the equinox. The precession of the electron around the atom is directly correlated to the strength of the magnetic field, because the magnetic field is just electron spin orientation. And by hitting a sample that's inside of a homogeneous magnetic field at exactly the Larmor precession, which is way up in the gigahertz, we're talking microwave energy over here, you're able to energize the electrons, and with certain materials, based on the hyperfine coupling between the electron and the core, you're able to then transfer the orientation of the electrons to the nucleus and slowly build up orientation in the core. Via pulse process, like you pulse it for a certain amount of time, that's usually in the milliseconds, and then allow that orientation to transfer to the core. And then you pulse it again and again and again until you achieve perfect orientation. And then what should happen is the object would become weightless and possibly even like lose its inertial mass. At which point, all you would need is a very weak thrust of some sort. Even like a light beam would probably be enough to shoot the craft off at a crazy speed if you achieve near 100% dynamic nuclear orientation in the craft. And if that were to happen, it's all theory. What the passengers in the craft would be experiencing. Would they be experiencing gravity? They're definitely not going to be experiencing inertia when the craft turns, because they're all in the same reference field. It's one way to explain the flying saucer phenomena, and it also explains why the craft look the way they do. The saucer shape, because if you just had a large electromagnet and you wanted to follow the laminar field lines of an electromagnet, they come out at like a plume. So if you were to follow it, sort of like in a canopy underneath and above, then you would essentially have the same magnetic field lines throughout the hull, and then you could pulse the microwaves at the Larmor precession, from the outside, and that will orient the craft. And this experiment, this paper written by Frederick Alzafon, was actually peer-reviewed, and his son wrote a couple books about it after the father died. There's two of them. This is a book of the same name, Gravity Control with Present Technology, and there's the top 10 UFO riddles. So basically, this book is kind of like a wish list of what would happen and how it will, be so great for humanity and whatnot. And it also goes a little bit into an experiment that his dad did, Frederick. He did it, kind of like us, on a shoestring budget. They borrowed equipment from a university. An EPR machine is one of the most important parts. Is the laminar magnetic field, or the homogeneous magnetic field, is pretty difficult to attain, and we can attest to that, because we've had a lot of problems shaping iron and getting the coils in the right shape. It's very difficult to get a homogeneous magnetic field. on a shoestring budget. And we have achieved a laminar magnetic field in a very small sample space. I'll show you the setup in a moment. But the energy levels that we're using at 20 watts, I don't think they're enough to say one way or another whether this effect actually works. So we're trying to up the power using a klystron. And I have the klystron right over there. It's capable of 3,500 watts at, I think it's somewhere in the C band where it operates. And we got a bunch of waveguides and stuff from a lab that's going out of business. And the power supply behind me, this big hunk of metal, is what's going to power the klystron. It's 5,000 volts at 0.5 amp. I've been having trouble. I was working on it the other day. I think one of the switches on it.
Mark, can I ask you a question?
Sure, go ahead.
Obviously, I don't speak your language, but you said you're going to go for 20 watts or 20 kilowatts.
Oh, so it was 20 watts originally with the, see this device over here? That's
Yeah.
the traveling wave tube amplifier. And that can only put out 20 watts. So we're going from 20 watts to about 2,500 watts.
Okay, 2,500 watts. So you're telling me, are you being successful at 20 watts?
We have not seen anything that really rose above the noise field. You know.
All right, do you see a threshold somewhere?
Yeah, there might be a threshold. And also one thing that David told me, which was very telling, is that when his dad did the experiment in '94, they achieved 80% weight loss within a second. And
80% within a second?
80% within, or even less than a second. You watch their graphs, it's pretty amazing. But he also told me that the sample heated up, which to me obviously means that they're using a lot more than 20 watts, you know, in their experimentation. And ultimately what happened there, the reason why we're not seeing, you know, flying saucers or craft based on this principle is because of the egos of everyone that was involved. They all started fighting over who owns what in a company that never existed. And then the university wanted their EPR machine back. And rather than tell the truth that they made a massive discovery, they went and just took the whole thing apart. And, you know.
So, you know, the question about you asking about a saucer, are you aware of what Paul Potter did per se and Andreessen?
I saw his book. I haven't read it or understood it 100%. I flipped through it, you know, pretty briefly.
If you go back to Meyer in Switzerland, he says that he put a microphone out there, and I've got it somewhere, but I couldn't find it to save my life, where there's a UFO over his head, and he's got it going, and his feel, you know, if you heard it, it sounds like rotating machinery. And if anything, it's like Searle's device where you've got some crap running around rotating. And that would be the ideal reason for why you're going for a saucer. Now, even if you look at some of these triangular spacecrafts, you'll find 3 or 4 circles, glowing circles, and I call them sphere constellations. Right. And I'm just kind of curious, are we talking about something close to that or not?
It's possible that it all is the same technology with different ways of achieving it. One thing that David Alzafon told me that his father told him is that this effect is also achievable through mechanical means, just using an electromagnet and having the aluminum disc. There's a reason why you have to use aluminum because of the hyperfine coupling and the memory effect of the metal. Ultra pure, you know, like 5-9 aluminum. You want very pure aluminum mixed in with a little bit of iron.
Okay. The thing is that in some of the experiments we ran, that the magnetic field is so strong, aluminum magnetizes.
What strength are you talking about?
We've done it on our energy box, which has about 1 Tesla or so, 1 to 2 Tesla. And the top part is a piece to hold the carousel together. And it's aluminum, about a 1/2 inch thick aluminum. And you put anything on there, it's magnetized.
We're not using anywhere near 1 Tesla. In fact, the highest frequency that we ran this experiment at was 9.5 gigahertz.
No,
And
no, I don't understand what that would mean. What
yeah,
I'm
so
saying is
in
by
Tesla is
Tesla, I mean,
0.3.
when you look at the strength of the magnets,
Right, right.
and start adding everything together, it comes out to a Tesla.
Well, if I could jump in real quick, do you think aluminum might be used to smooth out the magnetic field too? Because aluminum is diamagnetic, right? So what Paul, what you're talking about is with the energy box was more of an SEG style replication. So with something like that, where you got lots of magnets, big magnets rotating fast, you'd be probably diamagnetic magnetizing the aluminum. Which, yeah, but then what I'm wondering is with like when Mark was talking about creating that homogeneous magnetic field, right? Maybe you could use aluminum components to help smooth out that field, make it more even.
I'm kind of curious what he means by homogeneous field. Are we talking about something near points and sources, which means it's not homogeneous, or something that is there's no gradient?
There's no gradient, exactly. No flux in the field.
So that's a far field type of effect, though.
Right, right. So it's out in the open air where
So are we talking about a device that's doing this, or are we talking about riding on the magnetic field from the Earth?
Oh, the device itself is doing this.
Really?
Yeah.
Okay.
Can I jump in here?
Let me just finish one more thing, okay? So one thing that David Alzafon, which is Frederick's son, said is that it's possible to achieve this effect without microwaves through just by the dynamic nuclear orientation effect by spinning an aluminum disc within the laminar magnetic field. And when you look at the ARV from Mark McCandlish, that's exactly what you have over here. You have a aluminum disc, or they call it a flywheel, means that it spins inside of the center of a electromagnet, and that would be the most homogeneous spot in a magnetic field. And if that was dynamically polarized, the effect actually goes out beyond the disc itself. It's sort of contagious, similar to the way magnetism magnetizes things around it. Dynamic nuclear orientation, according to David, is contagious to the rest of the craft. And then the Earth's incoherent gravitic field then has to fight against it and gets weakened in the process. And then there's something in the base, or there's somewhere else in the craft that's actually producing, a traditional thrust, which could be, just 1% or less of the actual weight of the craft in order to move it around.
Mark, when I was talking to Mark's ARV, is that the circular part might be used just to generate electrical power. And secondly, it's like a distributor that sends all the electricity to each of these sleeves, slices of these huge pieces of copper. And he rotates it as a function of time. And that's how it's generating the levitation.
So you're saying that that this is generating high voltage field, and
Yeah,
and that's
that's
pulse.
one way. That's just one way of looking at it.
Yeah, it's listen. I'm not diehard set
But
on
but
this.
the thing you got to think about is that you've got these pi pieces here in the base,
Right.
and these are thick laminated, and they might be insulated from each other electrically. So they're going to generate some strange results. But the other thing is that the red thing is also a coil. So
Right.
you've got this slice thing together with its field, and you're coupling over another magnetic field, electromagnetic field above it with this other ring. So, this is like putting a piece of levitation over a piece of metal. Well, that looks great. If it's super cooled, it moves, and hey, that's great on a piece of metal. But can I do that in flight? Well, this concept might allow you to do that. So you've got the splice thing here and a separate ring around it.
Right. And you think the parallel plate capacitors in the base, they're generating a thrust effect? Is that what you're trying to say?
You mean for a thrust control system?
Yeah.
I got nothing to say about that. The only way you can do that is by regulating the voltage and the electric current you have over each of these slices.
Right, right. That's similar to what I was thinking is going on in the base, that there's actually pulses going through it, similar to the Podklanov experiment, the impulse experiment with Podklanov. Instead of using superconductors, they're just using whatever material was in there. And they're pulsing it very quickly in order to create some unidirectional impulse on the craft.
But I would say those tanks are probably for environmental control for the guys, the survivors, rather than having anything to do with propulsion or anything.
Yeah, I think so too. I think that there might be oxygen and hydrogen for a hydrogen fuel cell, which is how I would make a craft. Like if you're gonna fly in outer space, you're not gonna want to use a battery. Maybe a battery supplement. I was thinking more like the Toyota Mirai, mixing a hydrogen fuel cell with a battery system. And the advantage of that is that you have now water in case you're stuck somewhere. So water is a great thing to have in outer space. And also the water can be used as a spin ballast, because if you're spinning something around, there's a tendency for the craft to start spinning in the opposite direction. So you can have a spin ballast, like a tube that goes around the craft, and fill it with water and spray that out every once in a while if it's spinning too fast.
Hello, can I add something here? Can you hear me?
Hey,
Hello?
Do, Ron. Please do.
Yeah, okay.
Nice to see you here too, by the way.
Okay, hi, Tim. Yeah, three things. What I wanted to mention, are you familiar with the work of Colonel Rex Schleicher and his patent on nonlinear electromagnetic systems? No,
not yet.
Okay, a friend of mine, the patent, he was living in New Mexico, but the patent for Colonel Rex Schleicher NEMS, you can find that at Rex Research, nonlinear electromagnetic propulsion system. It was Air Force funded. I'm not even sure it's even open to the public anymore, because what it does, if you look at the NEMS patent by Rex, REXSCHLICHER, it's an easy find. It's about 15 years old. In my conversations with Rex, he talks about, are you familiar with the word cryogenic aluminum? There's a term called cryogenic aluminum. A cryogenic aluminum is on the verge of superconduction, but not at super cold temperatures. The next item I want to bring up, when Paul Murad mentioned copper, I guess people are familiar with the Wallace patents. The Wallace,
Yes, indeed.
Yeah.
the Henry Wallace patents, what he is looking at, Henry Wallace was a friend of mine. When I was at Villanova, he was working at General Electric Space Flight Systems in Valley Forge. And we didn't know it at the time. As I was going to Villanova, he was driving to Valley Forge Space Flight Center. And he has two patents, 3626605, 3626606. The patent was distributed because there's two technologies there. Hank Wallace, which can be found by rexresearch.com. There's also a neat introduction by the new scientist at the 10th anniversary of the Wallace patents were patented in 1970. Oddly enough, Valentine's Day, February 14th, 1970. And at the 10th anniversary, the British publication, The New Scientist, they had an article on, it's at Rex Research, they had an article on Wallace's patents, and it says the military was very upset that the patents were issued. It's all there at Rex Research, but the whole crux of the Wallace patents, which may be pertinent here, is he talks about when you get above, when you have lightweight metals, your number of protons must always equal the number of electrons. You can have less neutrons. When you get above copper, like when Paul Murad mentioned copper, if you look at the periodic table, and you'll see that heavier as you go to U-235 and so forth, you get excess neutrons. And so the candidates for the spin polarization of neutrons within a metal happens at metals above copper. So in terms of being a Wallace effect in aluminum, you won't see that. But as far as being above it, that's okay. I mean, you can get there, and but that's largely it. Well, there's a third item I wanted to mention. I got beyond myself. Rex Schleicher is interesting. Wallace was also fired. He was fired from General Electric, Valley Forge Space Flight Systems, and his friends. Wallace did a lot of energy-saving patent research for GE. He was a notable contributor. I looked up the list of his patents at one time, and he dated. His friend said, if you keep doing gravity research at the GE, they're going to fire you. And he laughed. He says, no, they're not going to fire me. And he was fired. He was terminated. As you know, Alzafon, and I know some people who like to remain hidden from Alzafon, but they got to survive Boeing after Alzafon. And oh yeah, then there's also Chekhov that I follow, and he uses the aluminum disc. And so in terms of the inner relationship, Chekhov of Russia, which I don't know is valid or not, but this is just, but cryogenic aluminum is unique. Also the work of Alzafon ties to this, but it's metals that are above the weight of copper. Oh, also the third item was on the McCandlish ARV. Everybody with me? And yeah, the bottom part of that, the dielectrics in there were quartz. The quartz comes in a chiral variety. You have alpha and beta quartz. There's a certain orientation to them.
Ron, sorry to cut you off.
Ron, I had talked to Mark McCandlish, and he specified to me when I asked him about what dielectric they used in those bottom plates that it was Herkimer quartz that they had specifically made by GE, no less.
Yeah, well, Herkimer diamonds. Are you familiar with Herkimer diamonds?
Yeah, we looked them up, and they have interesting dielectric properties and piezoelectric properties.
Yeah, like I said, quartz comes in chiral varieties. Type in alpha and beta quartz. And so in terms of the ARV, I really don't have much problems with the ARV. But like I said, in terms of dielectrics, also deep in my files, I go way back. I'll give you a brief insight. Does the name Redford mean anything to anybody?
Ron, getting back to the quartz, do you know any place where we can purchase the correct kind of quartz? And just repeat again what kind of quartz it is. Because
it's Herkimer diamonds. Herkimer diamonds is found in
It's in
Herkimer,
Herkimer, New York. There's a campground there. You can actually pay to and mine the diamonds. I've gone there.
Yeah.
Go out to the field and mine for diamonds there.
You could probably road trip it. You could probably road trip it, and because I looked online to buy some, and not as though I need them. Because at one time I was looking that I came across the patent. This goes way back into my files. I have about 100. My law was I could not have the number of ring binders exceed my age, but now they're up to 100. So the limit is 100. But in my files, there was a Russian patent, and it was on a material that was polarized that used a glass material, and it was a Russian patent. And the Russian patent, oddly enough, wound up in a company in Dayton, Ohio. And for security, the plant was located on the flight path of Dayton International Airport. And so in terms of having, I don't know if the Russians were trying to do something with glass, and there was no mention about propulsion. It was just a unique material, but the number of Russians on it were staggering. But anyhow.
Ron, can you put these things on, and can you put this quartz on sheets?
Well, a quartz is glass. I mean, you're talking about the.
Okay, because I keep looking at, something like this, like.
Yeah, I mean, you can roll it. I mean, quartz amorphous. The only thing is with quartz, the advantage of chiral quartz is by having chirality, you have handedness and you can polarize it. I'm not sure if conventional glass has anything. I mean, if you're going to polarize something, you need a dipole moment. And by virtue of having a dipolar, you have a thumb, you have a dipole moment.
Yeah.
You put that electric field and you're getting orientation. And so
the thing in looking in the ARV, what you're doing is you're concentrating one of those poles at the center and you're diffusing it all around the edge of the thing.
Yeah.
So you have what you're suggesting.
So, yes. So anyhow, like I said, in terms of where to work, if you can make a trip to Herkimer, New York, might even be on the thruway. I'm not even sure. But you can get a Herkimer diamonds for free. I looked at them, I'm buying them online, and for the price of them, I go, oh my heavens, if you live in Jersey, go up there and get a bucket full and come back, melt them. And I mean, if you want to do something that's ARV-like, myself, I got enough stuff to do. But anyhow, in terms of encouraging others, I just want to give people directions of where they could go. Also, in terms of Alzafon, does anybody know about the Penn State connection to Alzafon? The material science people, according to my sources, all this information that I say here is subject to a disclaimer that I may or may not be correct. It's the disclaimer. Anyhow, according to my sources, the Alzafon material was made at Penn State University, and since it was Penn State University, it may have been the Rustum Roy Laboratories. And I see a friend of Tanya Slowacki was here. But anyhow, the material was not a solid. It was a nano powder, according to my sources. And we were dealing with nano powders. You must keep them under nitrogen atmospheres. When you get down to metals at very, very small diameters, by virtue of the surface area and oxygen, they will explode upon contact with air. So in terms of dealing with Alzafon and sheets and stuff, even I wouldn't use inclusions. If you have a way of getting to nano powder aluminum, give that a try. Also, in terms
what type of aluminum, Ron? What type of aluminum did you say there?
Nano.
Nano pattern.
And that's it. Now Mark is holding up and actually, yeah. So Mark is holding up a bag.
Yeah.
That this is the finest aluminum powder we have. It's 5 microns a piece, 3,000 mesh.
Okay, I'm not sure. 5 micron. Okay. Like I said, in terms of what was made, I know it was made. It was custom made. Fred Alzafon did not pay for it. That's all I'll say. It was done by one of his business partners. And when they split up, the business partner took the powdered material. And so that's all I can say.
Like I said, it was destroyed by ego.
Yeah, well, yeah. Well, anyhow, I want to just go back a second. I knew there was something called PACE, Planetary Association for Clean Energy, held at the University of Toronto, October 1981. And it was one of the Woodstocks of anti-gravity, as well as Paul Murad's MITRE Corporation 2003 high-frequency gravity wave. But anyways, at the University of Toronto, we had about 10 copies of Alzafon papers, and we were staying at the Hotel Windsor on Windsor Street in Toronto. And at 1 o'clock in the morning of the first day of opening, there was a fire alarm. And we all went down to the bar. The fire alarm, the fake fire alarm, we were held there for an hour. We didn't realize till next morning, but people who had the Alzafon papers were stolen from them. And yeah, it was an AIAA paper, and we have no idea why anybody, but other items were stolen. But the people that I were with were people who were supporting Alzafon, and we were wondering why on earth would they go through our belongings? And they stole Alzafon till they got I don't know how many were involved. Somebody said it had to be the government of Canada or something, but why they would steal a paper that was published. But they also looked for other things. And when I was coming back through security I crossed at the Rainbow Bridge at Niagara Falls, and for some reason they singled me out. I told them I was coming back from the University of Toronto. They said, "Are you bringing any experiments with you?" And I said, "Well, No, I'm bringing nothing back with me, but it was an odd question. Why would
Yeah.
they ask me
Well,
something
Ron,
like
let me mute you
Wow.
for just a sec, and let me go back to Mark here for a
okay,
second.
I'm
Okay.
finished here. I'm good.
Okay.
So
Okay. Sorry about that. Well,
That
so
was actually very, very interesting.
okay. Well, and that was my worry was that we weren't going. I wasn't sure if we were going off track or not. Do you want me to unmute?
No,
Ron?
that
Because
wasn't off track at all. Actually, that was
I know Wayne had a question too. Wayne was waiting to ask a question.
Oh yeah,
so.
Wayne, what's up? Wayne is also working on Alzafon.
Yeah, so I have a question for Ron, but first because we're talking about Alzafon, I'll just show some of my my earlier the stab I took at this. Let me just flip my camera around here. So this beast right here, these are two microwave oven transformers, and what I did is, this is my attempt to make an electromagnet to get in that range of about 3,300 Gauss, which I did achieve. And then I hung my samples down there. But I wasn't able to get to the point where I could control the magnetic field very precisely. And then I was using this gun oscillator, but I wasn't able to make sure or check that it was actually emitting the microwaves. And this one here is rated for 9.4 gigahertz. So I got lucked out with this. I found a marine radar at the side of the road. And so I was basically trying to shoot it here at the sample. And then I was pulsing this at about 6 millisecond pulses, as Fred specified in his paper. So, and my results were inconclusive, and I made a YouTube video about the whole experiment. So I just wanted to share that since we're talking about it. And I have another setup on my bench here, which is kind of a variation on the concept, but I'll go into that a little bit later. And then my question for Ron.
How heavy was that device? How heavy is that device you're showing us right now?
This?
Yeah.
Well, these are two microwave oven transformers, so they're pretty heavy. This is probably 40, I don't know, 30 pounds.
Yeah, it looks heavy. And there's a piece of
lot
metal
of
behind it. What is that? Is that iron or steel or?
Oh, well, Ron was talking about the Wallace patents, which I wanted to ask. I had a question about, and I did kind of a study on Wallace's patents and his kinematic field generator and all that. So he talks about when you rotate brass or any metal with atoms that have a nuclear quantum spin number or a net spin. Basically, atoms with an odd number of protons in their nucleus have a net spin or a magnetic moment. So when you spin it, the idea is that the nuclei will polarize. And he talked about something called a kinematic field, which is related to the idea of gravitomagnetism. And he differentiated this field from the magnetic field in his experiment. He was able to, through his apparatus, to eliminate the possibility of, it's just magnetism, plain old magnetism, because this field, I don't know if I don't know my audience here. I don't know if you guys how familiar you are with it, but so he was able to detect a temperature change in a sensor, and he explained it as being, so as the nuclei polarize, there is a decrease in entropy, and so it behaved a little bit like a heat pump. So the degrees of freedom are lost by.
Is this the Unruh effect? UNRUH effect?
I can't say for sure. I think it might be related from what I've read about the topic, the concept of lens thirring and gravitomagnetism or gravitoelectromagnetism, frame dragging, All those concepts seem to be related, and astrophysicists believe that it exists, and they observe it in cosmic bodies, like really large bodies in space. But where Henry Wallace was really, I guess you could say, innovative was in considering what's happening inside the atoms, because you have the nuclear mass there, and it has angular momentum, so it's spinning about an axis. So if you imagine, you know, the nucleus of an atom being like a giant planet that's rotating, but just on a microscopic scale, then you should have theoretically these gravitomagnetic fields around the nuclei of the atoms. But they would only be around atoms with net nuclear spin, because, for example, an atom like carbon or sulfur, you have an equal number of protons and neutrons, so the net spin would be 0. So he talks about the importance of that. Well, my question for Ron was, how do you see that relating to, you talk about chirality and the Herkimer quartz and all that, and what concept is there a linkage between concepts here, or?
I want to, where was I? I guess, to Tim, you're familiar with the Wallace heat pump? He's a heat pump patent.
Yeah.
Okay, because what happened is, after Wallace retired to Florida, he died, and he had a brother. It was called War Associates out in Colorado. And the only interest, they had strong interest from the Germans in the heat pump patent. So in terms of materials, when you're dealing with metals, I think you're better off. It's hard to say. It's just one thing I want to mention before I forget: bismuth. Bismuth is heavier than copper. So in terms of being one of his materials, bismuth and mercury from the Vimana, and bismuth is legendary. Also, in terms of my research, that may be helpful. Is anybody familiar with the bismanol magnet? It's called bismanol, B-I-S-M-A-N-O-L magnet. It's made from two materials. It's made from bismuth and manganese. These are two materials that should not be magnetic. When you put them together as an alloy, they become magnetic. It was invented by the U.S. Naval Department of Mines. It's a material that somebody should look into. In terms of metals, I don't really get involved in metals. Herkimer quartz, by being alpha and beta quartz, that interests me due to its chirality. If you type in chirality and space-time, you will get thousands upon thousands of hits. A lot of them are spurious. If you type in Kajome, K-A-J-O-M-E lattice, space-time, you'll get interesting hits on the nature of space-time as being related to triangles. So that's about as far as I can go here. So I won't use too much time. So that's, I see Mark has something. No?
No, this is bismuth. I cast it out of bismuth, basically.
Oh, yeah.
I'm not really sure what experiment I'll try with it. I think really what I want to do is melt it down and make it into plates, and try that spinning experiment that he just talked about inside a laminar magnetic field.
I really think if you need to make it like a fine powder, because what I found is with bismuth, it's actually, as a solid piece, it doesn't attract much to a magnet, but when it's in a fine powder, it actually attracts to a magnet. So I think that the particles can orient themselves more freely when they're in a looser form, like a suspension.
Actually, bismuth is
It's diamagnetic.
Diamagnetic. It actually pushes away from magnets.
Yeah. Exactly.
No, it's actually magnetic. Well, I ground it down into a powder, some of the bismuth I had, and then I put a magnet near it, and sure enough, it was attracted to the magnet. Almost like iron filings.
That's very strange.
Yeah, totally.
That's why you can make the bismanol magnet. It was in operation until Alnico came. Alnico displaced the bismanol magnet. Bismanol had like a 3 or 4 year run.
Huh.
Oh, check this out. This is a This is the diamagnetic effect with bismuth. You can see the magnet kind of floating there. You guys see that?
No.
Got a flashlight from behind so you can see, because it's
Yeah, so maybe in that solid form,
I'm pretty sure everybody's seen it, but it's still entertaining. I mean, we threw that thing together. I went out to New Jersey to help Mark out with his gravity research projects, and we just kind of threw that thing together in an evening out of the fact that he had bismuth and apparently a metal smelting furnace sitting around for kicks, and there it is.
Yeah, can you see it floating? No, whatever, it's floating.
Ron, I had a question for you about these various materials. Now, in your patent, you talk about these this very strange material, which I believe is a liquid. Is that correct?
Oh, no, with the electrets, you have to be solid form.
We've had a lot of problems making electrets, and I'll tell you what, in all honesty, we could use a lot of advice because it's been a tremendous disaster trying to make them and failure after failure.
I've been with electrets for 23 years. You have to watch out for something called eutectic. When you mix certain benzochlorine materials together, even though they have melting temperatures of over 150 degrees, I'll use the word Fahrenheit, when you put them together at room temperature, whoops.
Is this like the drop of aluminum on a plate of, a drop of mercury on a plate of aluminum? Kind of the amalgam that it forms and the eutectic or whatever?
What he's referring to is that with these different dielectrics, when you're forming an electret,
I'm offline here somehow.
Go ahead, sorry, you're on.
No, you're online.
No, you just stopped talking.
Anyhow,
See you here.
I'm at Zoom sign up. I might log out and come back in. Hold
Okay. We can hear you, Ron, just so you know.
Ron, we can see you and hear you.
on. Okay, because all I have is a Zoom screen.
It's
What I
probably just
want to
hidden. It
say
gets hidden
about
behind
Go
Red
ahead,
windows.
if you want to come back and try to log back in to get your
hold on
video.
1 minute. I can come back here. Hold on.
Okay, wait.
I'm going to my email.
Okay.
I am at email.
Well, Ron, let me mute you for just a sec.
Okay, let's get back to the lab, I guess.
Yeah. So Mark, if you were talking about the ARV, I am probably the most ignorant person on this call, but I'm used to that. So, ignorance is my specialty. So with the ARV, how is that? Are you just kind of speculating that that's related to the Alzafon experiment, or was there kind of a connection that pushed you that way?
There is a connection, and it is basically the fact that there is an aluminum flywheel inside of an electromagnet, and according to Alzafon, this should create dynamic nuclear orientation.
Well, now, if it's okay, and I want to, and again, I do the ignorant questions that everyone wants to ask, and I get to be the dummy. So, what is it about the Alzafon experiment specifically? And the reason I ask that is, as we all know, there are probably 1,000 different ideas for anti-gravity. What was it that pushed you towards Alzafon specifically? What is it that makes this the one for you?
Okay, well, there was a lot of the ones before it. It's just my method of attacking the subject. I've gone down your path and tried the ion craft, and I even designed a new form of an ion craft, which is basically a ball on the bottom with a straw, and then you put the wires on top. It literally, a 5-year-old can build it. And my daughter, we actually had a whole bunch of kids over at the house, and we took out all the bowls, and you cover it with aluminum foil. You just press down the aluminum foil. You stick the plastic straw in, put the fine wires, and then we stuck it inside the Faraday cage, and we saw which ones flew the best. It was like a competition. It was a lot of fun. But yeah, I tried that, and then I tried pulsing the high voltage DC. That experiment was done very rudimentarily in my garage. I was working late at night, and I had this tiny little Faraday cage, and you could smell the the ozone coming off the thing. Every once in a while I had to open up the doors. And I basically hooked up a whole bunch of vacuum tubes. I actually have a mock-up build of this circuit right over here. And this circuit actually is in working order right now. What you got here is the high voltage line that comes in. Now, because we're using a triode vacuum tube and we're trying to max out the voltage, everything needs to be insulated. And everything is going to be high voltage as well. So this is coming in here, and there's a lithium battery that powers the whole thing, and that goes to 3 different probes. This is a DC to DC converter, which ups the voltage for the grid, and we need a negative voltage, so that's negative to the ground. And this is a DC to DC converter for the 6.3 volts to run the element. And this over here is like a fiber optic receiving chip that I added a MOSFET to, so that instead of, it's a high voltage MOSFET, you know, pretty fast.
Is this for Alzafon?
This is, no, this is for pulsed capacitor experiment.
Right. So back to the question of why we picked Alzafon. I think that was, we're just trying to knock out all the low hanging fruits.
Okay, so this is actually not a low hang. This is an experiment that I actually haven't finished yet. So I'm just trying to tell you, what I was trying to get to is that there's many different experiments that we would like to try. Alzafon, I first found out about it by being on Jeremy Riss's channel, and somebody posted it in the comments. They posted a link, and Jeremy Riss never heard of it before.
I'd never heard of it either, to be honest. That's all new to me.
Yeah,
but Ron has, but Ron's heard of everything. So
I don't know. Ron, did you hear about it from me, or have you heard about it before?
He said he knew some guys from Penn State. Ron, your mic's still muted.
Ron, you're muted still. Yeah, again, he was at a hotel. He was talking about a hotel in 1981, I think, where they were talking about it. So.
Oh wow! So yeah, he definitely knows the ins and outs of that.
Yeah. No, it's new to me though. I think I've seen references. I think I may have seen the name, but.
Well, there's something called the Sterniman, STIRNIMAN, Sterniman anti-gravity list. It goes back to Usenet. Do people remember Usenet? Usenet was bulletin boards before the World Wide Web existed. They're still there, buried.
How do you spell Sterniman?
STIRNIMAN, Sterniman anti-gravity list.
So getting back to Alzafon, what I found in Alzafon is a explanation that just made the most sense. It was the most coherent, explanation to what is actually going on. And it explained a lot of the phenomena that we see, such as, the craft is waving around a lot, and it shoots off with a flash of light. So I'm thinking, like, if you make the craft almost weightless, what are you going to expect? Like, it's going to need a very accurate thrusting system. So it might, sweep around a bit, or it might use light as a thrusting source. So you see the craft, like, it's hanging around there, and then suddenly it flies off at a great speed. Why is that happening? So what I'm thinking is happening is they're building up the dynamic nuclear orientation in the craft so that it's coming closer and closer to absolute zero. And then they're you're just turning on the lights, and they go flying off at a crazy speed.
Oh, well, can I interject? Am I online?
Yeah, you
Am I
are.
visible? What I wanted to say is, I guess everybody here knows about the RB-47 incident. No?
I'm not familiar with it, no.
Everybody here should, the source for Alzafon, the background, how Alzafon got into this, was something called, you can go online. It's called the RB, which stands for Reconnaissance Bomber -47 incident. It's available at the blackvault.com, a UFO site. It has the origin of the frequency. The RB-47 was an AWACS plane that recorded all the signal intelligence that Paul Murad knows about. The signal intelligence of a UFO was recorded over Meridian, Mississippi. They saw it on radar. They took all the radar downloads. It became secret. It got leaked out at an AAS meeting up in Boston about 10 years later. Somehow Alzafon got wind of it, and that became the basis of the Alzafon experiments. It was based upon a UFO observation by a precursor to an AWACS airplane.
Oh yeah, I read that in the book. Actually, it was pulsing at 2.995.
Yeah. It's all there for those who don't know where it is.
Right.
But that was the introduction, and I don't like the word reverse engineer. I find that just overused. But in terms of for those who don't know the origin of where Alzafon came from, and so that's all I wanted to say for now. So.
Oh, yeah. So thank you very much for that. Yeah, that AWACS plane interaction really, showed that something was going on. It was pulses of like every 5 or 6 milliseconds at the 2.995 gigahertz. And that sort of like brings up Roswell, if you think about it, because they were playing around with interesting radar back then. And what is radar? It's gigahertz frequencies. So if you're able to disrupt whatever's going on in the craft, then maybe you can actually bring it down. You can make its weight rise and rise and rise until it has to hit the ground.
Well, what I want to add for a second, are you familiar with the photographs of roads of the UFO after Roswell? There was a UFO over Phoenix that Rhodes had 2 pictures of that took place about a week after Roswell in 1947. Are you familiar with that?
No, I'm not familiar with that.
I'll give you the website. The website is for FORE Shadower, SHADOWER.net, foreshadower.net. And if you go to Google Images and type in Rhodes UFO Phoenix, you'll get the 2 pictures of them. And it was, so in terms of actually, I was never a fond of Roswell, but when I saw the photographs that were taken a week after Roswell, it makes you think. I mean, it's the only thing that, in terms of discrediting Rhodes, a lot of time was spent by all the government agencies to discredit him, even though he worked. I guess the name Lee D. Forrest doesn't mean much to people nowadays. He was 202 patents. He's the father of radio. So, but anyhow, that's my link. So.
Oh, okay. So what I really liked about the Alzafon experiment was that just made sense. It made a lot more sense than the other theories. What I was getting to with the impulse thing is I actually came to this conclusion with the conversation with Jeremiah that really what I'm dealing with there is actual thrust. It's a thrusting device. It's not the inertial mass cancellation thing. It's not going to get you into the air. What the most important part really is the dynamic nuclear orientation aspect. So that's where I decided to, put all my research. Jeremiah has a lot of experience with high power electronics. He's been playing with, the brute force method of anti-gravity. And he sort of came to the conclusion, and to me it makes sense as well, that when you're dealing with high pulses of energy, you are getting pushed, but it's more of a thrust. It's more of an electron rocket that is being created that allows you to push.
Well, I mean, let me just change the term electron rocket. It's not ejecting electrons. It's using fields, the fields generated by the motion of electrons and the fact that they take a transit time to move from one place to another in 3-dimensional space in order to produce a unidirectional force as a result of a phasing of these individual fields.
Okay, yeah, fair enough. So we're actually thinking of trying an experiment like that where we're going to have a capacitor bank discharge into another low voltage empty capacitor bank using a thyratron switching system to get the maximum impulse. And we can hang the entire thing up here in the lab and see if there's any actual movement and also check for ion wind at the same time. And I think that would be a very interesting experiment to try. We'd probably use the same circuitry that I had for that system, so you can have like a remote control and really maximize the tubes. But yeah, getting back to Alzafon, the reason why I was so excited about it and my excitement kept on building was that it finally made sense. Here was something that, explained everything away. It also explained where science went wrong. And
Steinmetz went wrong, you said?
yeah, science went wrong with the whole concept of warp space.
Oh, science went wrong. Sorry, I thought you said Steinmetz. My bad.
No, science went wrong. Newtonian mathematics and the warping of space mathematics actually come out to the same answers. So it's all a theory. And I'm sure Todd can get in on this a little bit more later. But basically, Alzafon is thinking of the universe in a totally different matter. He doesn't really think that space is warped. He thinks that matter itself isn't constrained to the tiny dot where it is. It actually moves out for the entire universe. So it's literally the definition of infinity. It's a single spot, but it's also connected to the entire universe. So
quantum non-locality.
Quantum, you can call it, there's probably a lot of different names for it, but yeah, that everything is connected on this fundamental level. And that really connected with me because it suddenly made sense. And when you have these two atoms that are connected to each other, they're going to want to come closer based on the way water acts in space. When it comes into contact, you have surface tension, sort of wants to clump together, and that's really the source of gravity. But these subatomic particles can only interact with something that is of their same spin. Otherwise, the fields wouldn't interact correctly. So that's where the dynamic nuclear orientation comes in. There's actually many different theories for the same experiment that would explain Alzafon. And I'm not really set on any one of them. We're just trying the experiment to see what happens.
Right.
Yeah, well,
we can tweak it.
I think it's interesting too. I mean, it matches a lot of the other ideas, right? I mean, it's a lot of this stuff is almost kind of like, you just have to look at like the aggregate of all of these different experiments and all of these different ideas. And it's like, where does that aggregate kind of go? And so it seems like it kind of fits with that aggregate. You're talking about spin, you're talking about fields. I mean, these are, yeah.
It's a very interesting aspect of science. And when you look into it, you find that the information that is necessary for this research is very hard to find. And the people who know about this stuff are very far. They're pretty hard to find. People that actually know about this stuff,
Yeah, Mark.
like EPR and NMR.
Mark,
Yes.
can I jump in here?
Go ahead.
Yeah. I've done a lot of work with what are called PCMs, phase conjugate mirrors, for electromagnetics. And it's the one area of research where it just isn't allowed by the NIH. I remember seeing a document back around 2005 forbidding research in electromagnetics, for these type of power systems. But that's the whole key to anti-gravity. Okay. Tom Beard spoke about this back in the 90s. And he said that when you have a large-scale negative energy effect, it automatically leads to a large-scale anti-gravity effect as well. And when I look at this ARV, I'm not seeing it, okay? I'm not seeing a large-scale negative energy effect, which is what you gotta have to do anti-gravity. That's the bottom line. Okay, so I'm working on systems to develop anti-gravity using large-scale negative energy effects, okay? So when I look at the ARV, I'm not seeing it. Where's the negative energy, okay? If you're gonna do anti-gravity work, you gotta work with negative energy, okay? And that's where you set up opposing fields. Yet they have broken entanglement, opposing magnetic, preferably magnetic fields.
Oh, Will, there actually is information on that specifically from interviews that we've done with David Alzafon, which is Frederick Alzafon's son. And in regards to the opposing magnetic field, so we first set up a fixed magnetic field, which is fairly laminar as we can possibly humanly get it. And what we then do is inject microwaves at an angle that will disrupt the magnetic fields of the material inside that sample that we're testing.
Yeah, that would be torsion.
Right. So the disruption basically wiggles those fields around, and it causes them to become displaced. And the basic theory is, and I'll I'll oversimplify it here, but the basic theory is you disrupt these magnetic fields, they decouple from the gravitational field as a result of the energetic state that they're in, and they're very large amount of motion compared to the normal rest state. So they're moving basically so fast as a result of these fields that are precessing them that they are now disrupted.
Yeah, you got to twist the field. Okay.
Can I add the point? Can I ask my point that I asked previously? The thing is with the ARV is you're generating an electromagnetic field with that sliced piece is there, and you've got that toroid, and that's generating another electromagnetic field. So you do have electromagnetic fields against each other, which is what you're suggesting you need for negative energy.
Okay, and then you got the capacitor on the bottom to set that up as a resonator. So you got a PCM resonator effect going on there. That's your negative energy, and that's what you need to do anti-gravity.
You broke the code, but I sort of disagree with your viewpoint that the only way you can do this is with anti-energy. And I think we got to look at it a different way also.
I think that's an interesting point that you brought up, William. And that's something that we can try in the coming months when we get everyone here in the lab. So we could try a parallel plate capacitor impulse, because I really think this is about impulse. It's about wave shape. It needs to be like a slanted sawtooth in order for it to work properly. You need to have a much...
Tesla in his original magnifying transmitter was a switch mode power supply. He's probably one of the very first ones to do it. But then he set up his opposing field action as PCM using opposing magnetic fields, and then he had his capacitor network, and his load was his output transformer. Okay, so he was working with PCM.
He did call it with the magnifying transmitter. It was really a switch mode power supply. When that thing would channel ions down, there was a delay between the output field and the ion drift going into that potential. So once the ions were established and they were inflowing into the opposite potential set up by the magnifying transmitter, they would enter the circuit and be fed back into the generators.
No, if I could jump in, Bill. So Bill Alec is an electronics engineer, and so he's actually building these experiments too. I don't know if you built this one, but Bill is building stuff as well. So Mark, when you talked about doing experiments, that might be something Bill already may have experiments, or he may have models or something like that.
I'm very curious, Bill, about what you're saying, because I've studied this quite a bit from the perspective of Tom Bearden, and he talks a lot about negative energy as well. And I have a DVD where he talks all about negative energy flows and Floyd Sweet's vacuum triode amplifier, and how that thing, when he put it under load, it just lost weight and levitated, and it got cold at the same time. And it got me thinking about the negative energy and how that ties into the Alcubierre warp drive. How in his equations it requires negative energy to create kind of an expanding space. I guess that's how they explain it. But
so
the Dirac C, the negative electron holes in space and stuff like that. So yeah, interesting.
So now, in terms of the Alcubierre drive, I read something about that. I think this might have been Eric Davis who said that. But what he had said was, because the need for negative energy in that case was massive, right? And it was like we can never achieve all of this negative energy. I remember reading something that had said if you spin the fields, the spin basically reinforces the negative energy. So you can use the spin to reinforce that. And
it's called the Barnett effect.
Okay.
So what I was saying is,
link on the chat board here.
So what I was saying earlier is that we're going to actually be trying this experiment to try to pulse these parallel plate capacitors. And one option would be to have an electromagnet coil, maybe at some distance or right on it or across it while we're pulsing it, to see if that creates, a bigger effect, a bigger or smaller.
Well, you need a large-scale negative energy effect, which of course leads to a large-scale anti-gravity effect. Bearden actually said that in his lectures. So back in the 90s.
I had a question related to this for Ron. back to the materials side of this stuff and what kind of materials we can use to basically produce these negative energy states. What did you think about the U.S. Navy patent there by Sal Pace, and that was talking about that? I think it was a type of zirconium material. It was similar to, it was a piezoelectric effect that they were using to generate room temperature superconductivity, and room temperature superconductivity that could be generated by using these piezoelectric materials and squeezing them to produce these negative energy states that, like, what I use the condensed matter term for them, which is polaritons.
Well, I want to say, I think it's some of these materials. I was in contact with Sal Pace before he got clamped down upon, and I guess he's down in Hampton, Virginia, Hampton Roads, with the Patuxent Naval Research Center. And anyhow, piezoelectric materials. I tell people what makes our cell phone work is the piezoelectric in a cell phone is an electret. It's a mylar material. And so in terms of having a polarizable material, they have to be quartz. If you look at chiral quartz, by virtue of a lot of your early frequency, a lot of your early electronics, your early microphones, quartz goes way back into the history of electronics. And so when Sal Pace got into piezoelectrics, I go, well, that's, when you're dealing with piezoelectric, you're breaking symmetry. And that's what you need for these devices, is simple breaking of symmetry. I don't know where, but I think it was diselenide. It was a zirconium diselenide. There's a whole series of diselenides. So that's all I can say. What I wanted to interject here, when you were discussing waveforms, if you look at the patents, the nonlinear electromagnetic propulsion patent of Colonel Rex Schleicher, you will see in there, he has a dedicated, it's not quite a sawtooth. You might want to look at the waveforms. If you're interested in waveforms, look at the waveforms of Colonel Rex Schleicher's patents. It might give you an insight. It's something I don't do, and that's all I can say. It might be helpful. That's as far as I can go.
Well, thanks for that. My next thing was a question about this material that you're trying to create these negative energy states. There's a couple different things. We were talking about some of these metals and stuff. I recently came across an article of what they're doing at the University of Rochester, and that they're basically taking metals, and I'll share the link in the chat, and they're doing laser etching of the metals, and they basically create a microscopic pattern, or they basically turn the metal into a metamaterial by etching it with a laser and etching certain patterns into the material. There's a guy I mentioned before, David Cohen, Nathan Cohen, I think. He owns Fractal Antenna, fractantenna.com, and they have a bunch of contracts with the Defense Department on some of these devices that use fractals, fractal electronics structures, printed fractals, to basically, because they interact with the electromagnetic waves in enhanced ways, kind of like metamaterial would. And that this type of laser etching of these types of metals is a way to create metamaterial structures that are much smaller than the scales of these. You know, you have to create a structure that's smaller than the scale of the frequency that you're trying to manipulate with the nanomaterial, with these sort of metamaterials. So these this is an interesting method that I've come across. Posted the link in the chat to this, but they talk about warp drives, right, and wormholes and stuff like this, right, in the article. A very interesting video too, illustrating the whole idea of like these what are called surface plasmon polaritons. It's similar to it's a polariton, but it activates only on the surface of materials. And we were talking about these ideas for really low power craft that are able to, you know, function with light. in ways that are really advanced. I think this is the kind of materials we really ought to be looking into more deeply. And I think this is indeed what the government's researching with their studies. Because I keep finding I found that terahertz research group at Wright-Patterson that was connected to that. They're doing some type of top secret research at Wright-Patterson with the terahertz team there. And I know that those guys are experimenting with similar types of materials. And I just wanted to interject with that to put that on the table with this talk of the negative energy states and the types of materials that we might want to look at and look into.
Okay, so getting back to the experiment that Bill actually just enlightened me on. When we're doing the impulse parallel plate capacitor experiment, I think it might be interesting to see what happens when we add either permanent magnets or electromagnets. Probably easier to just put on permanent magnets on either side and see if there's any added strength to the effect, or whether the polarity matters, or it'll be a very interesting thing to look at. So I was thinking of probably getting a set of disc-shaped magnets with a hole in the center for the leads, and you just put that around a disc-shaped parallel plate capacitor, and impulse it with crazy amounts of energy, which Jeremiah is going to be coming down here to the lab, and we're going to be working on a whole bunch of these experiments, and I hope to do this a lot more often, and I hope you guys are enjoying yourselves. 1 second, I'm just going to try sharing the screen. We have a little flyer that we were working on the other day. Can you guys see that?
Good.
Oh yeah, so it's just a nice logo. I thought we'll call this the Alternative Propulsion Engineering Conference, because what we're doing here is we're trying to concentrate on the engineering side of anti-gravity, how the nuts and bolts of what actually happens. So yeah, the first Zoom conference is today, and yeah, whatever, maybe in the future we could have schedules and
yeah, I think things are going pretty well. I'm excited. I'm excited to see all these folks here. I appreciate Bill and Paul and Ron, and I don't have the whole list. Tanya, and I mean, we've got a pretty good turnout, and it is exciting too to be able to kind of focus more on engineering stuff. Things tend to get lost in the mix otherwise, but.
Right, and that's why I wanted to concentrate on the engineering side of it. And I thought it was actually pretty amazing that the Alternative Propulsion Gmail account that I wanted for this conference email was actually available, like alternativepropulsion@gmail. So we're getting synchronicity here, and I'm loving the name. And that's the goal. What do you guys think of it?
Okay, good. Hello? Am I here? Am I hearable?
Yep, you're hearable, Ron.
Yes.
Well, I came across something I sent out. I don't know how many copies. A lot of people go to phys.org every day. I don't know if they use it or not. If you go to phys, it's for physics, phys.org, there's a new quasi-particle, and it has to do something with negative mass, negative energy. It's a new quasi-particle. It was on phys.org 3 days ago, and they use iron and selenium. If you want to, I will email it to you, because I'm running low on batteries. In about less than 10 minutes, I will be without phlogiston. So, but it's about 3 days ago. If you type phys.org quasi-particle selenium, it should come up on Google.
Mark, can I ask you a basic question?
Yeah.
My basic question is, I don't know too much about some of the guys in this group. You guys are apparently building or trying to build hardware. What do you do for a living? Is it part of your job, or what? I'm looking for possibility of an organization, formation, or what's your motivation? What do you intend to get out of all this? And what happens if something happens where we break out with some levitating devices? I know what's going to happen is people are going to go in different directions and it could get messy. So give me an idea of what's going on. Do you, the space research company, is it your company doing for your dollars, or is it just something you're
Okay,
putting
so
into the fund?
let me explain that to you. So basically, this is a hobby that really took off. There is no LLC or company set up, under the name Falcon Space. I chose Falcon because my last name is Sokol, which in Russian means Falcon, and Falcon Space, it sounded really cool. And I used the logo from my actual business, what I do for a living. Here, let me disconnect over here, and I'll show you what I do for a living. Does anyone here have a Prius?
Have a what?
A Prius, a hybrid car.
No.
Well, hybrids are about saving the planet. That's what we're trying to do. So this business I started about 8 years ago with absolutely no knowledge. I've never really even graduated high school, but I'm an autodidact, and I learned all this stuff on my own. When I replaced a battery in a broken Prius, I realized that there's a massive market for it. And I figured out how to refurbish hybrid batteries, basically nickel metal hydride batteries. And then I quickly realized the equipment to do so didn't exist, so I had to build it myself. So this machine you see in front of you is called a prepper. Basically what it does is it charges the battery rapidly in series and discharges it slowly in parallel. And the reason why you have to discharge in parallel is because nickel metal hydrate has a voltage drop when it reaches full charge. It's similar in build to a hydrogen fuel cell. Actually, I had a guy once who bought some scrap nickel metal hydrate cells in order to take them apart and build hydrogen fuel cells out of it. So I thought that was pretty cool. And it also recycles the energy back into the grid. So it's all about recycling. This company is basically a recycling company. And then
Well, I guess what I'm saying is where you're getting the bucks to do all these things. Pieces of hardware, it's kind of costly. For example.
Okay. First of all, pieces of hardware are not that costly. Pieces of hardware are sometimes hard to find, and what you think about, you bring about. So if you want it, you got to think about it. That's the way the world works. Check out this.
I don't think it does.
It does work that way.
Sounds like a concept.
Oh, okay. Hear this story. So basically, I needed a traveling wave tube amplifier. I thought that was the best way to create the microwave energy necessary for the experiment. And I quickly realized that they are very hard to find and that most of them are broken. And I found some guy selling one on eBay, and he promised to give me a full refund if it was broken. This was after I already had a broken one. And he gave me a full refund and didn't even want me to ship it back. So then I opened it up and I realized that the low voltage side for the tube was broken. Fixed that, and the thing works. So it was a much simpler problem, because when you powered it up, it didn't turn on at all, which for engineers is the best thing ever, because that means it's probably a simple fix.
Okay, Mark, the reason I'm asking the question is that, I've been in a lot of aerospace companies. I've been in the government. And when we made the Morningstar Energy Box, the cost of the parts by itself was like $300,000. And the total cost that we spent was like, I would say almost $750,000.
Oh, wow.
And, it was, we put this thing together. It's a pretty serious device. The first approach was to make it a magnetic motor, but that didn't happen because, I had heard all the great things that the Russians did with Goodman and company. And it turns out that when we did our thing, we ended up with some weight loss as a afterthought. And when one of the Russians went to the meeting that I gave, he suggested that half of the things they suggested they didn't do, and we were more successful than they were. So, and then I look at Podelnikov with his spinning disc problem, And I looked at the pain and the anguish that NASA Marshall went through to get that. And there was a serious effort on their part. They never did go that far. Well, they had a 6-inch or an 8-inch disc that worked. When they got up to 12 inches, when Ning Lee was there, they ended up with a crack, and you're not going to spin that up at 3,000 RPM. You'll have pieces all over the place.
No, they
And
weren't doing the experiment. They were doing the impulse experiment.
No, I'm talking about the spinning superconductor part of Podolnikov's experiment. He ran 3 experiments. 2 of them was the spinning conducting disc, and the other was the gravity pulse device.
You're talking about Pakhanov, right?
Yeah. Maybe I'm not pronouncing it right.
You all have trouble pronouncing his name, to be honest. It's not just you. It's not.
Well, he made a confession later on that it would have cost about $1 million to make one of those superconducting discs.
I tend to disagree, and I think Jeremiah is probably the best example of that.
Oh, really?
Yeah. I mean, Jeremiah needs to turn on his camera and start showing you some of the shit he built out of trash. Like he would go through the dumpster and he pulled out a broken laser printer. Do you know what's inside of a broken laser printer?
Laser.
No, there's high voltage components. You got rectifiers, high voltage capacitors, all for free.
Oh, geez. I just threw away one.
Yeah, basically my prerogative is, I have a long history in the industry. So I worked for a motor winding company, a battery restoration company, a calibration company. For 8.5 years, I've got my CCT certification and spent a lot of time really getting methodical about these scientific tests because I have a very analog, almost robotic approach. You guys know Data from Star Trek. I have that kind of approach to this research. And so I guess you can consider me the resident skeptic and calibration technician. But my approach to this has been to take a lot of these really fantastic claims from patents. Boy, do I love patents. And from various other documents throughout history and really try to test them. And so far, I've been doing this for 21 years and I haven't really received a whole lot of tremendous results. For the most part, I find that there are many measurement errors that come up. And because I think a lot of experimenters, even those qualified in universities that have done their due diligence in the field.
Time out.
Go ahead.
I have heard so much BS from guys that were replicating the spinning disc problem.
Yeah, amen to that. There's a lot of errors.
The argument was, hey, I should get results with my 6-inch disc or my 4-inch disc at 800 RPMs. And they go do it, and nothing happens. And the bottom line is that sometimes you got to go through a threshold. And this Podolnikov's experiment and this guy's replication is a separate experiment. Mm-hmm. So the bad thing about it is when you start getting negative words where, hey, this guy's stuff doesn't work. Why would we want to look at his gravity pulse device?
Right, exactly. That's why we set up this conference, so that you can literally see the experiments as they're being built and point out any errors.
Are you guys going to put something like that together?
We are working on
it like that together. That's pretty simple to put together.
Well,
I mean,
what I got to say is be careful going backwards because the backwards will get you the Hutchinson effect. You got to push one end.
We're hoping for John to be on here. He has a lot of interesting experiments, and I have all the equipment right here in the lab to try all of it. And getting back to what you were saying about the where the money comes from, so far I've been using as very limited amounts of funding to purchase the equipment behind me and all around me actually. Jeremy Riss is another example of what you think about, you bring about. He kept on searching on Craigslist for a lab that was going under, that was selling out. And he went and found this massive power supply behind me. And then when I saw that, I was like, holy crap, get that power supply because I can use it to power a Klystron, which I already knew where to buy. And we can try the Alzafon experiment in high power. And that they gave it to him for $50, which is less than the scrap value of the copper. So you can get stuff for dirt cheap if you think about it. And if you
There's
want to,
MIT Flea Market, there's Brown University, a lot of these I live right in New England, so we got Harvard, MIT, they get new equipment. They have really well-funded schools with really well-funded labs, and they're constantly replacing and getting like brand new equipment all the time. So they have these fleas like 3 or 4 times yearly, where they get rid of old equipment at a pretty good price, reasonable prices. But nothing beats going on like Craigslist and the Facebook yard sale groups, and I just type in laboratory equipment, and I do that like pretty much every week.
So you're from the Boston area then?
Yeah, I find a lot of stuff around here.
Mark, where are you from?
so I'm in Hawthorne, New Jersey. We're the SpaceX of the East. SpaceX is in Hawthorne, California.
Okay.
So anyways, yeah, I got all this equipment pretty cheap, and I was using, of course, funds that I got off of the from my day job with the hybrid batteries. And we also got a couple donations recently. We got a pretty sizable donation, and that's going to sponsor. We're going to rent a house and have a couple engineers come down here and actually work on these experiments. If anyone's interested in coming down, we are an open source lab. I do not believe in secrecy in this field, and I'll tell you why. It's because there's nothing to be gained through secrecy. You literally should just put everything out there, and the industry that will open up on the other side of anti-gravity disclosure is so large, you're guaranteed a part of it, so you don't have to worry about money in the future, because it's going to be an industry that will literally transform humanity.
Mark, I understand that the internet's a technology leverage to the rest of the world, but I disagree with what you're saying. And I could give you examples about Ning Li and so on. But, I guess the question here is, I appreciate what you guys are saying and what you're telling me, and I have somewhat of a calibration where you guys are going. Can we go back to the original objective here to what you guys are doing and how far you've gone so far?
On which experiment?
The Alzafon experiment. Apparently you're saying to me, I've got the impression that you've done some duplication of his work.
Oh yeah, okay, so let me show you the entire Alzafon experiment. So this is the setup right now, and we are going to change it soon.
Guys, I have to, I promised my wife that I would eat, so I have to bail out for a little bit.
Oh, okay. 1 second. Before I go, for Mark.
Oh, well, no, I don't think it's ending. I just have to run out the door. So I just want to let you know.
Just put the settings so a speaker view for everyone. I think you got it right now.
Yeah.
1 second. Okay. Can anybody hear me?
Yeah.
Can Mark hear me? What I wanted to say, I'm low on battery. I'll be out of here. But for Mark, are you familiar with testing a AA battery by dropping it? Have you ever done that?
Yeah, that has to do with the alkali system. Basically, an alkaline battery goes from basically being a solid to being a liquid when it's discharged.
Oh, is that what it is?
Yeah, so there's water in there that
okay.
Yeah.
Because I was wondering, have you ever weighed your battery charged versus uncharged?
It weighs the same. It weighs the same.
Does it? Okay, because I always wondered.
The difference in the drop test, and the reason why it works, is because the hydrogen and the oxygen are inside the anode and cathode, and then they combine together to become water when it's discharged, which is the opposite of a lead acid battery that it becomes water when it's fully charged.
Because I have one material that when you get it cold, it goes liquid. It goes to liquid. So I can't use it. So, okay, well, it was good talking to everybody. I'm going to, before I crash here and lose my computer stuff, see you next time, and good to see you.
Hey, Ron, before you run, I have just one last question for you. Any way to contact you? I have some contact information for you. Is it okay if I send you an email and try to get some info on maybe how to test some of these other materials that you talk about in your patent, maybe where to find them or how to set up?
The trouble is, they were at one time made. In your old capacitors, they used the term was hollow wax. I don't like to use the word hollow wax because what I use, hollow wax was at one time used widely in capacitors and transformers, and then they were regulated out of existence. But yeah, beam me an email and I will answer what I can. So, okay.
Thanks. All right, man. Have a
Can
good,
you
have a great.
tag me in that email?
The 2020 Woodstock. Nice meeting everybody.
Okay.
Thank
Okay.
you, Tom.
Thank
Thank
you,
you,
Ron.
Tom.
Okay, good.
Thanks a lot for joining us. You were very informative.
Welcome.
Okay, so you're asking about the actual setup. Over here we have a signal analyzer that goes up to 22 gigahertz. That set me back $1,000. This is the signal generator. I think it was at like $300 or $200. The traveling wave tube amplifier, like I told you, it ended up being free. This is from my hybrid battery business. This is, I don't know, $5, something like that. It's basically a shunt that we ended up shunting a little bit more. Jeremiah actually helped me with the DC power supply. We had to change out the pots in the front because we really just care about the current control, which is why we have the shunt, you know, to measure the current, because we're powering an electromagnet, which is on the other side of the wall, that is doing the laminar magnetic field, and it's important to keep the magnetic field exactly the same strength so that the alarm morph frequency is hit. You see all these holes in the wall? So I could change the light. Those holes go into a Faraday cage, which is on the other side. When we turn on the experiment, we have the on and off switch over here. This turns on an alarm on the other side. And this is our Faraday cage. Like I said, it's the size of a room. And the alarm switch to tell us it's powered up, but it's not powered up right now. This Faraday cage is one of the first things we built when I decided to do these experiments, you know, in higher power and try stuff for real. There's a grounding rod in the center that goes down 8 feet, and 1/4-inch aluminum panel, which connects to an inner seal, and then there's an outer seal that goes to a separate ground. And I'm not going to go too far into the cage because I probably will lose signal at some point. Let me see if I could make it into here.
Mark, I used to work for Bendix when I was putting together a hardware in a loop lab. And we were concerned about stopping the signals from Teterboro Airport. So we had to make sure these things were really closed up. And I see with the holes, are you filling those holes up and around the enclosures for electrical power?
Oh yeah, for EM pulses. Yeah, of course we have caps on it. So over here is the actual test apparatus, and the first thing we noticed is that the scale is affected by microwave energy. So we had to shield the hell out of it. It's literally covered with several different layers of aluminum over there, with grounding cables. And Tom, one of our scientists who shows up here sometimes, actually suggested to get a ribbon grounding rod that goes straight down, which I think is a great idea. We're going to try that for next time. But we were able to remove the noise during our null tests. There was some considerable noise before we were able to remove it. So it's very important that the scale be grounded if you're using a piezoelectric scale. I also got a mechanical scale, which won't be affected by RF, but that scale has it's extremely sensitive. So we wouldn't be able to measure full weight loss. We'd be able to measure if there was X amount of weight loss plus or minus. You wouldn't want to be inside this chamber while any of these experiments were going on. We tried using a mesh Faraday cage, and both a mesh around us and around the test subject, and we were just getting headaches. So we decided to move the entire experiment inside here. Basically, this is our electromagnet, and as Jeremy calls it, it's the EPR NMR laminar spintronic alignment rig. So over here we have a, this is where the test sample is, and it's basically a 3D printed setup that allows it to slide pretty smoothly up and down. This test subject is put in there. We have a whole bunch of different types of test subjects that we plan to try based on all different theories. back over there, we have a Yagi antenna for the signal analyzer, so we could see actually what's coming out. There's also a capacitor to smooth things out for the power supply. And behind this is a salt tank, which basically acts as a load, so that there's less reflected energy. In the future, I plan, basically we're going to make like a fish tank kind of device out of wood that's going to go across this entire back wall over here. And we're going to fill that up with salt water for the more high power experiments. I think that's an important feature, because you don't want the microwaves coming back and hitting the sample at a different angle and screwing things up. What else? We plan on making the electromagnet possibly larger, because the space in there is too small for a 6 gigahertz waveguide, which is another issue. So we're going to have to get a lot more iron in order to work that out. And I was just having a conversation.
You can use a 3 gigahertz though, 2 to 3 gigahertz. The RB47 numbers.
No, we're going down to 6 because that's what's available. Basically, the lower in the frequency you go, the weaker the magnetic field needs to be, but it still needs to be very homogeneous. So
we just got a 6.2 gigahertz series of waveguides for free, and then he had purchased a Thyratron for that as well. But that's a good observation and thing to point out, because I wasn't even aware of that case being the inspiration for Alzafon's theory. That's news to me, so it definitely should be worthwhile to try that if that's what
Focus on it. Focus on it.
We will focus on it, and I expect that a full-size craft would probably go in that frequency. But the effect is the same no matter the frequency. You just need stronger magnetic fields. That's the only difference. And for a full-size craft, yeah, we would go with 3 gigahertz probably, because you don't want to be sitting inside of a half a Tesla field. You want it to be, it's 28.025 gigahertz per Tesla for, I think, the valence electron in aluminum. Me and Wayne and this guy Pablo, who works in an NMR company, we're going back and forth about affecting the other electrons, the deeper second, third, fourth, fifth row, depending on the material you're dealing with. And there are different or more frequencies for different electrons. And if anyone has any paperwork on that, that just shows all of the elements and their isotopes and the different or more frequencies in relation to Tesla, that would be something very useful.
Well, the reason I mention this is if people look at UFOs and they're 100 feet away from them, they turn on the radio and it doesn't work. Now you can stop a radio from using 5 watts, but they change the frequency and they're all off the air. So this damn thing, it's 100, 200 feet away. That's got at least a megawatt of electrical field. The bad part about all this is nobody can tell you what the magnetic field is. So you might want to look at this from higher values rather than lower values. But if you can make it work with lower values, God bless you.
I mean, that's the goal. We can only work with what we have. And right now, the universe gave us waveguides that are actually tuned to a very specific frequency. So I got to, the theory should be the same based on, it's just a combination between a homogeneous magnetic field and microwaves. And if we could stick to one microwave band, a frequency, then we could just dial the electromagnet up and down, and we'll have to figure out how to make that dial as accurate as possible. And eventually we'll hit the dynamic nuclear orientation state, at which we'll be able to determine whether something happened or not.
Another thing I just wanted to point out, Paul, is that there's no clear indication that radio interference is actually part of the propulsion system itself. That could just be, they could just be shutting off your radio to prevent you from being able to communicate as well. I'm thinking, because 200 feet away, that's got to be far field effects. And my theory on these skin coatings and the materials that they use is that they recycle all the electromagnetic fields with the near field, and that there aren't really a lot of far field effect, like the far field effects are minimized.
Well, let me go a step further by simply saying, I asked you this earlier, and I don't know if I got a response. Are you aware of the Paul Potter concepts?
That's the onion drive craft, right? Where they ionize the air and pull it, right?
Well, what is he talking about? He's talking about 3 balls that are rotating, 3 or 4 balls that apparently act like a magnetic field. There's a ring in there, so you have like an electromagnetic field that you see with the ARV. And then with all this crap is going on, which indicates one thing, that ET knows his electrodynamics down pat, they're throwing in some microwaves. So you're dealing with all these magnetic fields, electric fields, and you're throwing in microwaves just for the what? So you have
dynamic nuclear orientation. That's why you're throwing in microwaves. You're trying to make the craft weightless so that you need less thrust, which can be brought about by other means. Is anyone religious over here?
All right.
My takeaway from the Bible is
yeah,
why.
go ahead, let's hear it.
Okay, just one short thing. My takeaway from the Bible is, why did God need rocket thrusters to land at Mount Sinai?
What? I give up.
He did it.
So anyways, I was getting a little cramped over there inside the Faraday cage, but there's also an isolator, and then there's a waveguide, and then there's a 3D printed wave horn, which is, these are all things that we're kind of confused about. I don't have too much experience, building waveguides. So if any of you know somebody who has some sort of knowledge in that field, that'd be very useful.
This is my 3D printed horn.
Yes, Wayne.
I don't know if that works or not, but I tried to design one off of a Wikipedia article about microwave horns.
All right,
So,
you really need a signal generator so you could see what actually is happening.
Yeah, and a spectrum analyzer too, right?
Spectrum analyzer, that's what I meant. Yeah, a spectrum analyzer to see what's going on. A signal analyzer.
And I got this. You were talking before about coming across things in just a timely way, and this is part of that marine radar thing I picked up at the side of the road. I mean, who leaves a marine radar out on the lawn? I mean, it's kind of unusual. I'm like, that's for my Alzafon experiment. There we go. Thank you, God. So
maybe there is a law of attraction, Mark.
Yes, there definitely is a law of attraction. If you think about it, what you think about, you bring about. It's that simple.
I don't see any supermodels around.
Been around for a long time. The idea of actually putting your human efforts towards a single goal is certainly a powerful idea, but there's no need to bring in any kind of superficial or metaphorical or supernatural ideas into it. Quite frankly, it's just a matter of the fact that your actual actions create the real opportunities that you experience. And it doesn't need to be more complicated than that, really. I mean, it's deterministic, basically.
Okay. Yeah, so moving forward, I have to fix this power supply behind me and hook it up to the Klystron in order to try the Alzafon experiment at a higher power. And I got some waveguides over here, a whole bunch of pieces that Jeremy picked up at that yard sale. And it's really equipment that we need, but you mentioned money. Somebody actually recently donated some Bitcoin to help out. And yeah, money is great, but really what you need is equipment. You need equipment and time. Money's just a number.
I had a conversation with that anonymous donor last night too. I want to go over that a little bit, Mark, because he said that one of the things he pointed out was that we have to become self-funded. He can only donate so much and for so long. You know what I mean? We need to, at some point we need to have a product and sell that and become kind of self-funding to kind of keep this going. You know what I mean? That's sort of we talk about immediate goals and long-term goals, short-term goals. I think our short-term goal should be find a way that we can make some kind of product and become self-funding, and find some way to fund the lab. We have enough smart guys here. I know we've discussed a lot. I won't discuss all our intellectual property here, but we've come up with a lot of good ideas for inventions of just things we can build and sell on our websites.
Let me give you some advice for all it's worth, okay? Let's say you come out with something great, game-changing technology, and it works, and you validate it. And then what you should do then is keep your mouth shut, build the piece of hardware, and when you're ready to get it going and sell it, then you go get your patents. Okay?
I couldn't disagree more. I think what you have to do is go on this chat group and show everybody else how it's done, and just let the world change on its own. Because like, you can't be greedy. You can't be asked.
We've had this discussion, me and Mark, and we believe that other people have discovered this before. And when you go to get the patents, that's when they get you, because you haven't told anyone yet.
Well, let me give you another example. One country used to rip off our technology. And while we were developing that technology for weapons, they were able to take our ripped off technology operational faster than ours. So you don't want to have the attitude where you want to build something and you got a concept and somebody rips off your concept and they build it before you do.
I would just send in my resume and ask to work with them. I mean, that's what I would do. I just want to build the darn thing.
I think what we're doing, and I believe in this, is that we're building a community through our YouTube channels and stuff like that. And so building this community, and when we stumble across something that actually works, or we discover the principle or the secret, the ingredient, then what I'd like to see happen is to teach as many people as we can how to replicate it. Because until we overcome that initial skepticism, there's no market for this. There's no money in it. So skeptics have to be able to have the recipe to replicate it and build it. And just like Michael Faraday discovered the relationship between electricity and magnetism and how you could have a magnetic field around a current carrying wire. And then, so he discovered the basic principles. So I'd like to see those basic principles be discovered and then share those principles. And then all of the business applications, all of the technology, all the different embodiments, which mean getting patents, right? Because you're now developing business, but I think that would come later once we get over the initial.
Well, it's nice to be gratuitous and generous to the rest of the world. But let me give you another suggestion. If you put together all the pesos, you can make a bigger thing, whatever you're going to make. And that can have a bigger benefit rather than putting it in your pocket. But you want to be in control of it because you know what the hell you're doing.
I don't want to be in control of it. I want it to be to go out to the masses. These are people, the Wright brothers were people who tried to control it. They actually got a patent on ailerons. And we all know you can't build an airplane without ailerons. And where did that leave the United States? At a severe disadvantage going into World War I. And one of the Wright brothers actually suffered a heart attack based on the lawsuits that they were fighting this motorcycle company, Curtis, I think. It was all over ego. So I think the main problem in this field is there's, people get into their specific theory or something like that, and they're too they're too fixated on it and they can't see themselves possibly being wrong. So it becomes hard to work together. I'm trying to overcome that by just sharing everything. You know, I have no specific agenda toward any one technology. I'm just excited about whatever I'm trying, because you got to be passionate about it. You got to think about what you're working on, which is one of the reasons why all these other concepts that you guys are talking about, I'm not necessarily even that learned in it. I think Jeremiah and Tim are very learned on all these other theories, but the one that I'm trying, we try to stick to, and I don't agree with the whole patenting thing. You can patent it way down the line. I think the industry is so big that nobody needs to be worried about, you know, getting hired in making this stuff happen.
Well, the question here is, you know, you said you'd rather join that company. Why not make your own company? But then, you know, it's a question of your leadership capability and your management capability. And okay, I'm sorry.
I don't want to be the manager. I don't want to be the manager. I would prefer to find a professional. If I were to start my own business, me and Jeremiah would like to be like the chief engineers, but I wouldn't want to be managing the business on a day-to-day operational scale.
Well, Mark, what I've learned in life is that if you want to lead a company, you got to do it in management to introduce your ego into the direction of the company. And by saying that, I don't mean ego in a negative fashion. By an ego, I mean your ideas and where you're headed.
Oh, my vision, yeah.
Yeah. So, you know, people have done it differently. You can talk about Tesla himself, and you can look at Edison, and the other opposite, where it turns into General Electric. But, you know, that's your preference. And I just, like I said, I'm sorry for interrupting everybody else in the audience, because I just want to get some sort of calibration of where this is going and what happens after it's done.
Well, after it's done, we're going to try to get the word out there as quickly and as publicly as possible, and you know, bring about anti-gravity disclosure, showing everybody how it's done. And it might be a combination of several things, and I truly believe there's more than one way to do this. So I'm not discounting anybody's idea. I love every idea that I could try in the lab. If you got a theory out there that has no application to a laboratory, I'm not interested at all. And that's really, you know, where we're trying to differ from the ST Spark conference, which I was at. They're trying to push the thing toward wormholes. And like, have we ever even seen a wormhole? Like, it's insane. I prefer to go towards the engineerable side, because that is what's going to change humanity, and that's what's going to bring about anti-gravity disclosure, and, you know, finding the real thing.
You know, and if I could jump in, you know, I should apologize. I kind of came halfway into this, but, you know, like pretty much everything that I ever did in this area is all open, you know, and Paul has done so much that's open also. Now, like with Morningstar, right? That was Paul. That's your guys' intellectual property, and I think you have a couple others that are IP as well. But then when you step back from that and think about how many scientific papers have you written, reviewed, peer reviewed, all of that stuff, and those are all public. So really, you know, all of us are kind of doing open source, and I tend to agree with what Mark said a while ago. Of there have been dozens, maybe hundreds of companies, right? Like, I mean, everything from magnet motors to free energy to anti-gravity, where somebody feels that they found something, and then the potential for money and the egos and all of that, it just tears things apart, you know? So in a weird way, the open source approach to it seems like maybe that's a path around it. And I know it has some dangers, right? Because then somebody could take your idea and run away with it. But then on the other side, you know, it helps. And then I also think that we're kind of getting into things that are too big for one person, right? And it helps to be able to share. I mean, so Yeah, I tend to go with that. I see Jeremy making hand motions.
Well, you know, in Morningstar, the three of us must have put out about 30 or 40 technical papers in 10 years. But let me go back to an earlier comment made. What I see is that if you're a physicist, these guys are coming out with ideas, great ideas about anti-gravity. And Jack Sarfetti, for example, I said, hey, great idea, Jack. Sounds fantastic, but I'm an engineer. Can you build it? And the response is, so all I'm saying is that you got a disconnect between the guys that think they know what's going on and the guys that can do it, and they don't communicate each other because they can't. The technology's not there. And it's one thing to go around and say, hey, Alcaberry, he's one guy, for example, mathematician, not even a physicist, a mathematician. Ask him how to build that. Can't do it. Now, Todd's got some ideas that I remember seeing about some antennas and so on. And I thought that was a pretty interesting approach to take. But you're not going
Todd's actually in our WhatsApp group, and I contacted him through Twitter. I think I found him and got him on WhatsApp as well.
Yeah, I had originally reached out to Todd because I had read some of his papers and with my research into the Hal Puthoff stuff that and the work that he did with Alfonso Rueda and Bernard Hayes, all their theoretical papers on starting with in 1994 with the polarizable vacuum approach to general relativity and all these subsequent papers that they've worked on. And a lot of those studies were related to Lockheed Martin Skunk Works studies on this stuff, which is interesting. But they all talk about this polarizable vacuum, but I like that Todd pointed out that you can't polarize vacuum, and instead we have to look for some other types of materials or something else that we can use in order to build and actually engineer this.
Well, you know, and I mentioned this to Mark the other day on a call. It is interesting, the incredible loops that people will try and jump through, just not to use the word ether, right? It's, you know, I mean, because, and I think
I can't hear this. I can't hear this.
Yeah, exactly. And you know, and it's interesting because I've heard that many times. I've had ether. Well, you know, are you so? But
Dirac
it is
Dirac C.
Yes, Dirac C.
Dirac C.
Yeah, or you know, and yeah, even with the Mach's principle stuff, it seems like it comes back to that. It's like, you know, these are all in a weird way. So who knows? Maybe that word will make a comeback, you know, at some point.
The fact that you mentioned this, the reason I ask you about that homogeneous magnetic field is that Shipov put together a homogeneous physical vacuum. Dyatlov, who I was dealing with before he died, believed in an inhomogeneous physical vacuum. And what he did is he looked at objects that had some disparity or discontinuities between one physical vacuum with another. And this would end up with things like ball lightning, UFOs, ghosts, and spirits, that instead of being homogeneous with a given field, electric, magnetic, and gravitic field, the anomaly is working with a different electric, magnetic, and gravitic field. And there is a boundary around it. And, you know, that's why I asked the question about being homogeneous.
Well, the purpose of the homogeneous magnetic field, or I like to call it laminar, because that's just the word that comes to mind when I'm flying my paramotor. But basically, the point is that the connection between the Larmor frequency and magnetism is, you know, it's just an equation, and of 28.025 gigahertz per Tesla for the valence electron. And if you want to interact with it throughout the entire sample, you need the homogeneous magnetic field. Otherwise, you're going to end up with, you know, the Larmor frequency only reaching one point, and then in some other points it might be out of phase, and you might end up with no result because of the that the fields themselves are inhomogeneous.
Let me ruin the rest of your day.
Go ahead.
I personally feeling from just this conversation, and I don't claim to be an expert, you're not going to get any levitation unless you've got something that's inhomogeneous.
Okay, we could try that. How homogeneous do you want it to be? Like how much flux?
A black hole is represented as a gravitational singularity.
Mm-hmm.
Let me put it this way. Let me back off a little bit. If I make a supernova occur, a red giant star explodes.
Okay.
If the mass is 2.4 times the mass in our sun, it puts together a neutron star. Now, the gravitational attraction of a neutron star is really, really, really higher. For example, if you have a binary system, binary neutron star, and it had the same footprint as our Earth going around the sun, where it takes our Earth a year to get around, in the same footprint, the neutron the binary pair can do it in a week. Okay, now if it's bigger mass than the 2.4 times, and you have a supernova, you end up with a black hole. Now here, a black hole doesn't have a high gravitational pull. It has a singularity. So its gravity is infinite at the center. Now, how the hell does that happen from one mechanism by making a bunch of neutrons in there, where the explosion, the implosion of the supernova is so big that it pushes electrons and protons together to form neutrons, and then you form this in a crystal, and it becomes 10 to 30 kilometers in diameter, and it's got its gravitation, and then I got this black hole, which I don't know shit about, and the black hole has infinite gravitational attraction. Now that's
how about I explain it to you like this? First of all, we don't know that a black hole has infinite gravitational attraction. We just know that it's faster than the speed of light. It might go down to a singularity. If it goes down to a singularity, that would also fit in very well with Alzafon's theory.
It's picked up as a Gordon, not a Gordon, a Einstein somebody bridge.
Let me finish with this. Okay, so basically, Alzafon looks at every subatomic particle as basically just a point, like a very sharp waveform that goes out into infinity. So it's literally the essence of infinity in distance, because you have
it's a singularity.
Well, you're talking about like a matter wave. You're talking about a matter wave, right?
I'm talking about a matter wave. Yeah, a single that every single subatomic particle is actually a singularity, and what it's doing is it's stretching out to infinity, but there isn't enough attraction on at distance to create much gravitational pull. But when you have enough matter together, they always attract each other because they're trying to go to their lowest energy state, which is like to combine together. Similar to the way we see water acting in outer space, it sort of conglomerates around one ball, similar to gravity. So he's trying to explain it away as a more of an electromagnetic effect, which would have the exact same theoretical prediction of a black hole, and you'd actually have the same math for it. What I'm trying to say is that Einstein made a mistake, and I don't know this for certain. Okay, this is just the theory. When he said that it was warping space-time, really what they proved was that light curves around the sun. It curves around. Electromagnetism is affected by gravity. Now, what does that tell you? Are we talking about warped space, or are we talking about just electromagnetism is attracted to gravity? That's really all they discovered. The fact that he theorized it beforehand doesn't mean anything. I have 4 different theories as to why Alzafon would work. Like, seriously, it doesn't prove either one of those theories. And the fact
I would agree with that. I would agree with the general principle. I would say that one of the reasons that you do, that I did, that Bill is doing experimental research is because there are more theories out there than there are experiments, right? I mean, and that's really the same reason Paul did the SEG is, we've got 101 theories and really only 4 or 5 experiments that are worth trying, and so, yeah, I would say in principle, I mean, and it is so hard to tell. Also, one of the things I found with theoretical stuff is, Well, number one, the people who develop it, right? Like Jack Sarfati has I cannot get a good description from him of what he's doing. He's like, well, this is battle tested Einsteinian physics. And I'm like, okay, let's do an interview. But I can't do an interview unless you can tell me what questions to ask. And I don't know what the hell you're saying, you know? So,
don't feel alone about that.
well, it's the communications gap, right? I mean, and it makes sense, you know, and I think one of the other
let's go back to the situation you just talked about. I've got a light beam. I'm next to it, and it's going to go straight. But in Einstein's experiment, they ran the beam, looked at light, it went by the sun, and all of a sudden, light was bent. Why? Because of the gravitational attraction on the sun at that magnitude, which is much higher than it is when it goes by me.
Right.
So this is raising the point that I'm suggesting earlier, that you got to juice up the electric and the magnetic fields to get anything that you want to get any gravitational effects.
No, we're not looking for gravitational effects. We're not creating gravity here. What we're creating, and don't like look too much into the word anti-gravity. What we really just mean is anything that can explain a flying saucer. So put the word anti-gravity aside. We actually changed it to alternative propulsion engineering conference. We're looking for alternative propulsion, something that is different from the mainstream that would allow us to fly it at crazy speeds. And this effect is a gravity shield. We're shielding ourselves from gravity and possibly from inertia. And there's reason to believe, you know, two different ways, so whether it's gravity shielding that creates inertial shielding and so on and so forth.
Well, the equivalence principle states that your gravitational mass and your inertial mass are the same thing. So if you can do one, you can do the other. Theoretically.
Yeah.
Theoretically, this is actually an interesting way to test it, but it would, I don't know if it would prove either theory because they both fit. And there's actually another theory that I'm not allowed to talk about right now, which is going to be kind of interesting if they ever publish their paper, that has a whole nother theory on Alzafon and why it would work, which is not mutually exclusive to the other theories. And Todd has his theory, which keeps on changing every time we talk to him. And everyone can have their theories. I have no problem with theories. We just got to try experiments and try to really understand what's going on. And I'm all about the lab and the equipment and actually getting those experiments done. Paul, you mentioned that you've done some stuff in this arena.
Well, let me suggest that the way the conventional wisdom operates is that you consider the conservation of momentum, energy, and mass. I think the problem is we need to look at the conservation of fields. And that might be the way out of this. And that's why you don't need negative energy, negative mass to solve this problem. But who's been doing that kind of work in terms of any analytical approach? Sarfati makes that suggestion, but apparently it falls on deaf ears. Now, I had to review a paper by a man that's in prison forever, and he had a very interesting concept. And the concept was having two gravitational fields interact with each other. But they don't interact in terms of merging, but as inhomogeneous or with a boundary. And I'm thinking about this, where you figure with two gravitational fields, hey, it's going to meld together. We do that with our planets. But he's saying, no, the distinctive boundary, and when you go to that distinctive boundary, you move at the speed of light. Now, he's got no theoretical representation of making that, but it's an interesting concept. And I guess who would have ever thought of gravitational fields doing that way? Now, you use the word gravitational shielding. This is apparently what a UFO does. It sets itself in the inhomogeneous physical vacuum, like I mentioned earlier, where you've got a boundary and you're operating.
Why do you say it's homogeneous? And maybe it's homogeneous,
Yeah.
Maybe we're inhomogeneous. You know, the planet Earth is inhomogeneous, and the
Absolutely.
is coherent. It's, you know, all coherent.
Absolutely.
Yeah, that's what we're trying to do. So we're saying that, you know, the second law of thermodynamics states that everything goes toward chaos. So why wouldn't we expect the subatomic particles in an atom to be in complete and utter chaos? And if they are in complete and utter chaos, and we orient the nuclei of a craft into a coherent state, it will disconnect from the chaos that's around us. And then
you see that with quantum effects, actually. What you're describing, right? Jeremy could probably back me up on this, but what you're describing is, well, like, okay, you take a superconductor, and this is one of the things that has kind of piqued my brain, I guess, for years, is you have macro scale quantum effects. You have things that are kind of decoupling from time space, right? Like a Bose-Einstein condensate is another one where you remove enough energy that gets to it, and then you get these strange behaviors because you're kind of, in a sense, you're almost like changing the dimensionality of it. But what you're talking about is, if you align those spins, right, which is supposed to be, it may be similar to what's happening with like a Bose-Einstein condensate with the Cooper pairs that travel together and stuff. If you're able to align those spins, it's possible that you could be getting this thing to function as a single quantum field in a way, right? And, you know, and there are lots of examples of, like a good one is the superconductor over the magnetic rail, right? You have the rail, you put the superconductor on it, and you can tilt it, and it maintains its orientation. You get lots and lots of really interesting effects when you get into quantum scale stuff on a macro scale. And it sounds like that's what you're describing doing here. You know, except instead of Cooper pairs, it would be every particle in it, you know?
Exactly. Every subatomic particle inside the atom itself will be oriented through the dynamic nuclear orientation. And it will basically act like a top, you know, that you're free to move it on any, along its plane and along its axis without any resistance. But if you try to, you know, spin it or something like that, you get, you know, these torsion and a conservation of angular momentum, you know, makes it spin in another way. And something that I theorize, is my theory on Alzafon, for all it's worth, is that subatomic particles, the random spins in the subatomic particles are what causes inertia. Because when you throw something, you know, you're changing its relativistic movement through the ether, which I'm pretty sure exists. And it changes on a subatomic level the spin orientations of the subatomic particles inside that baseball, and that is where the momentum energy, the inertial energy, is stored when it hits, you know, another object that is at rest relative to it. So that's just the theory coming on the inertial dampening side of it. But like Jeremy said, there is an equivalence factor, and whenever you lose one, you will lose the other. The question is, which one did it come from? Who knows? Doesn't matter, as long as it works.
So we don't really know what gravity is, but we know an awful lot about electricity and magnetism, what electricity and magnetism are, and that, you know, electromagnetic waves are actually light, and they travel at the speed of light. And part of the theory that I've been working with is very, very similar to all this, and it's all about, everything's at an incoherent state, or an inhomogeneous state. And that we're trying to resolve that and get rid of this inhomogeneous. It's an inhomogeneity in the fields basically around us, which I believe is causing the effects of gravity, and it's all electromagnetic. That the graviton is basically it's like an illusionary force. I think the whole idea of envisioning things in terms of electromagnetic fields and forces is kind of like where we almost went wrong in the whole physics model, because what we have is when you have an electromagnetic field, if you put a charge E times Q equals F, you know, that will give you a force, and that's the force that, you know, that's the force that the mass will feel, and we'll get an acceleration proportional to that. So the way that fields are designed is that we remove this charge component, and then when you put the charge component in the field, it gives you a force. but it's not that the charge, that there's a field there, because the field may not be there. Maybe the charge itself is what's actually generating the force. And it's not like the presence of any field. The field's sort of imaginary, and we can kind of measure it by putting something in there, but it's just a theoretical abstraction that we've come up with to basically do our math in terms of the Newtonian physics way of that it was first derived in Principia, right? With accelerations and masses and accelerations. So, but the quantum theory of this is all like different. We obviously know it has something to do with condensed matter states and some kind of quantum effects, right? These superconductors, rotating superconductors have this whole thing. What's going on there? We haven't really figured it. We haven't really resolved the anomalies that have been discovered. It's not quite anti-gravity, and we know that Bose-Einstein condensates and simple, quantum behavior, condensed matter states don't necessarily lose their weight. So that's not the whole puzzle either. It's not. It's obvious that there's something more going on, and I think it's optical, because I think gravity is transmitted on electromagnetically with optics, and I think that the way to do it is with these surface optics.
So Jeremy and Mark, you've helped me with something I just thought about in a different manner. Sarfetti found something out about 10 years ago, and it was based upon some papers by JPL on the Pioneer 10 and the 11 anomalies. Now what happened is they cut off all the systems. Hey, it's past Jupiter. Who needs to do this? I need 30 people every day looking at this thing. It's costing too much. Let's close the sensors. So they closed the sensors off. And a week later, the guy says, let me go find the Pioneer. Goes look for it, and it ain't there. So they started looking for it, and they found it 1,000 miles away. Well, gee, I know what G is equal to 1 over R squared. What's wrong with this damn thing? Then they looked at the other one, the same thing happened after Saturn. They just go bananas. Well, it turns out, if you look at the rotating of the stars in the rotating arms of spinning galaxies using the Mund approach, as well as this Oumuamua celestial visitor comes in here, that gravity apparently becomes a constant. In other words, its value is like 10 to the minus 8 meters per second squared, compared to 9.8 meters per second squared around the Earth. And what this is doing is that you have the Earth, just like you guys are saying, it represents an inhomogeneous quantity, and we're in this homogeneous quantity, which is at this ridiculous gravitational level. In other words, you have 1 over R squared, bingo, constant. Now, if you look at the cosmic signal noise for the Milky Way, it's 2.73 degrees Celsius, something like that. What the hell does that mean? Well, if we talk about temperature, then we're talking about energy. And if we're talking about energy, we might be talking about matter waves. If we're talking about matter waves, gee, we're talking about gravity. So I really don't need dark matter. It's there.
It's there in the cosmic microwave background radiation.
Absolutely. So all this crap about dark matter, hey, I need matter out there. As a matter of fact, the guy doing Mund said he was the first one to figure it out, that there's not enough mass out there. And everybody says, well, gee, there's mass out there and I can't see it. It must be dark. Does it interact with other things, electromagnetic fields? No. Okay, so there's this dark matter that has no electric field and no magnetic field. Now, if you believe in UFOs, you're cruising along at warp 2, warp 3, warp whatever you want. And if I hit something at those speeds, I ain't going to make it. but these UFOs seem to make it. So maybe there is no dark matter. All right, now we realize this, 1 over R squared, and then all of a sudden a constant. How does that change our views? Anyway.
You know, Paul, if I could jump in real quick, this, I don't know, 10, 12, 15 years ago, you were telling me, I forgot his name, was it Dilatov? The Russian? Dyatlov. Was this the fellow who measured, I think this is a different person though. So he did the measurements on the radiation coming, or the gravitational pull coming around the moon during an eclipse, right? And he found radiation coming.
No. I don't know who you're talking about.
Okay. I'll have to, you know what, let me look him up real quick.
Okay. So all I'm saying is that, all right, that sort of crystallizes in my own mind what we're talking about, what I'm seeing. And I'm rather pleased about that. Maybe I'm kind of egotistical. What the hell? I can be egotistical at my age. Okay, I'm sorry, Jeremiah.
So back to what I was thinking about resolving this, the inhomogeneity and making things clear again, like to take away that basically if this is microwave background radiation, right, and it's all microwaves that's pervasive all over the universe, and we also observe these UFOs, you know, emitting these microwave frequencies, then maybe, you know, doing microwave invisibility is kind of like a key to this, and or some type of, you know, some type of optical effect with regards to microwaves. And so that's why I've been looking into like these the quantum states. So one of the things I found is these things called squeezed coherent states. And if you take these coherent states, you get coherent states with coherent matter in a condensed matter system. And then if you squeeze those by limiting their position factor, right? Then you get an increased optical resolution, and it can kind of resolve that inhomogeneity, that noise. I think that might be something we might want to look into a little bit as far as the experiments go. So I want to get more involved in the optical materials, and I want to reach out to the University of Rochester. I'm trying to obtain a piece of metal right now that I can bring there, and I have an idea for how to get them to laser etch it and do the type of laser etching, but I want to see how much that type of treatment would cost, because I want to build one of these systems with these laser etching for microwave waveguides, and try out some of these, try out hitting with some frequencies and trying to produce these squeezed coherent states around the entire object and see if that will reduce the gravity.
So you're talking about making a waveguide using laser etching?
Yes, I'm talking about, yeah, we're gonna, you know, make like a piece of metal, a metal object, like, I don't know, we could, I'm not sure the exact shape I want to do it in yet. Haven't built an AutoCAD 3D file for it, but I could get this shape manufactured.
That's actually very interesting, because I was just looking earlier today at getting a CNC machine, and they offer them with the laser as well as the drill point. So we could try the laser etching inside the waveguides.
That would be amazing if we could etch it on with the laser etching with a 3D printer as well. This is what I'm talking about. Yeah, we get a surface, get it polished smooth, and then we laser etch it with this this thing. I think this is more close to how these things operate. This is amazing stuff that they've done. They just by laser etching these metals, they've turned them hydrophobic, hydrophilic. They turn them into waveguides for different types of optical materials. They can change the color.
But we're dealing in microwaves, so you'd have to get the optical equipment as well to run it at the specific frequencies you're looking for. And as I am aware, there are some lasers with a Zener die that you're able to change the frequency a little bit. But moving light around,
gigahertz, just like Paul said, that's what I want to look in. That's where I want to explore first.
Gigahertz? how many gigahertz?
You said 2 to 3, right? Was the
2.6 to about 3.
2.6 to about 3. Yeah. Ultimately, if I were to build a full-size craft, I would go in that route. Thing is that the bigger, the lower the frequency, the bigger the waveguides get, and everything starts to get really large. And the effect should be there with higher frequencies and higher currents as well, and smaller equipment that could fit inside our Faraday cage. But ultimately, yeah, I do want to go down to that level. There is a lot of equipment in the 2.5 to 3 gigahertz range. The trick is getting the homogeneous magnetic fields. Because those are pretty weak magnetic fields. You're talking on the order of like 1,500 Gauss already. And for every Gauss, you're off by, several megahertz. You need to get the entire thing, let's say like 1,500 Gauss or something like that in order to run that experiment.
Before you do anything, like I suggested to you earlier, look at Paul Potter's concept and see how that impacts electric fields, magnetic fields. And you got a handle on ARV based upon what we said. And it's enough to cross your eyes. So I'm not going to sit back and say to you, hey, I fully understand Potter's concept or Andreessen's concept.
I don't understand it at all, but I know that he was mixing microwaves and electromagnets. And to be honest,
look at the geometry, and then start saying to yourself, what if this metal had this way or that way, and what kind of fields would you have? And the one ring may have a tube in it that is flexible and is filled up with a liquid. Now, one of the experiments we used in the Morningstar energy box was, I'm a cheap guy. I did not want to put in big, heavy magnets. So I used ferromagnetic fluids. I also used high mu 80, which is 80% nickel, stainless steel. Now you touch this stuff and it's got no magnetic field at all. You put in a magnet next to it and bingo, you got a magic magnetic field. It's unbelievable. And you put that into this device with 1 Tesla worth of natural magnets. You might be coming out with 5 for all I know. And you throw in this ferromagnetic fluid with a rotating magnetic field for sure. But it's moving at different velocities than the actual rotation of the 3 spheres. God knows what's going on. So
that kind of fits in with dynamic nuclear orientation as well. Having spinning electromagnetic fields, because you're basically, instead of spinning the disk, you have the electromagnetic field spin around the disk. And like I said before, I'm pretty sure there's more than one way to anti-gravity or to dynamic nuclear orientation, and you might have just mentioned another one of them. But like Tim was saying earlier, there seems to be like a connect between many different experiments with this whole dynamic nuclear orientation idea, which is why I'm so excited about it, and why we're going to try moving into higher power levels. And here's some equipment that we have. This is the Klystron. It's a C-band Klystron, and it's capable of like 3,500 watts. The max voltage is 8.15,000 at 1 amp, which is a crazy amount of energy. The power supply behind us is capable of 5,000 volts at half an amp, which, at 2,500 watts, maybe we could up it a little bit. But it should be putting out at least 1,000 watts, which is several magnitudes higher than the 2,000 watts 20 watts we were doing before. And in terms of waveguides and all that equipment, so Jeremy, along with the massive power supply, also got all this stuff. This I got off of eBay, but everything else here he brought in with him. And there are these tuned waveguides, and this guy had a real hard-on for 6.28, 6.2 megahertz, or 6.2 gigahertz. And everything, all of these wave guides are actually tuned. You can see the exact wavelength. He put like little blockers in them. There's a whole bunch of them. I have no idea what he was using these for.
He did biological research, according to the notes and stuff we found around the labs and the notebooks and stuff. And he also did some classified research in terms of metal coatings and different types of coatings on copper, like electroplating and other types of coatings. And I think that the microwave stuff was for some types of tests that he was doing with the coatings that he was developing.
Say you went to the estate sale and you picked up all the secret tools they used to test Russian aircraft.
Let me ask you guys, have you ever worked with a million volts?
Oh, Jeremiah can answer that question. He had he had unmarked vans circling the block for a couple hours. Jeremiah, are you there? Jeremiah? Oh, he's probably away from his computer.
Yeah, I'm on another call right now, Mark. I'm sorry. I'll have to get back to this a bit later. I'll have to review it, but I'll catch up.
Okay. Yes.
You said he was working with 1 million volts. That's DC, right?
Impulse. Mark's generators.
Oh yeah, yeah. Okay.
And he was working with very high voltage and very high current as well. So massive discharges, and he saw a lot of crazy things happen, like things would disappear and reappear elsewhere. And
Philadelphia experiment.
What?
Philadelphia experiment like thing.
Yeah, Philadelphia like experiment type of things. And we actually plan on replicating some of those experiments in the lab over here. I want to do them inside the Faraday cage and see if I can get a gravitic pulse, as they call it, outside the Faraday cage. And,
well, Maker was doing a test or an analysis at 511 kilovolts, and he ended up with some very interesting responses. Now, what is also interesting is 511 kilovolts is similar to the energy you need to pull an electron off an atom. And might be some way, some place you want to look at too. Gentlemen, I've enjoyed it. I'm an old guy. It's time for me to go to bed.
Thank you
Paul,
so
thank
much,
you for
Paul.
thank you for coming.
Thank you. It's had a good time. Bye.
We'll do this again.
Awesome.
Okay.
Thank you.
Oh,
Come again sometime.
Yeah. Does anyone else want to introduce themselves? I see we have Tachyon Aerospace, and you in the center. I don't see a name. And we also have Monomorphic.
Oh, David. We have David.
Oh, David. Hi, David.
Sorry, it doesn't show your David. It didn't show your name until we went over the. Yeah, no, Mark. I wanted to ask with this. I would love to be able to put part of this. Maybe we could email the folks who attended. I would love to be able to put part of some of this up. Just again, the dialogue and the discussion. Hearing Jeremy talk, you talk, Paul talk, Bill talk. And the exchange between you, right? This is what educates people. This is what educates that next generation of, 15-year-olds who are out there reading science books.
Yeah, I would love that idea.
It educated me. I learned a bunch of stuff that I looked up that I hadn't heard about. So this was great.
Yeah, we have to ask everyone, if anyone has any objection to that. But like I said in the email we sent out earlier, we are going to make this video available to everyone who's been here, so everyone can at least see it. It's going to be published but unpublished on YouTube, so that nobody can find it without.
Yeah, I would just ask if we publish it, maybe we could just block out the attendees so that people who want to attend and remain anonymous can do so.
That's a great idea. Bill? What do you think?
Mark?
About the conversation. We're talking about what to do with the video, because there were so many interesting things that were shared.
Well, I don't know, post it on Facebook.
Okay, there you go. Well, we could probably trim it down into parts, right? And And then like Bill, if you're okay with it, if Ron Kita is okay with it, you know, and then basically just kind of put highlights up rather than having to put everyone there, you know, but we could ask.
Right.
Yeah, and I think it would be interesting to do one of these again. I mean, there's a lot more, I mean, excuse me, for instance, I don't think Bill was able to share that much about what he's worked with, but then you also talked a lot about Mark McCandlish. We could probably get Mark to come on a call. There was, I'm trying to remember who else. There was another person that you mentioned a fair amount. We could probably try and get them on as well. So
Kletnoff?
maybe, yeah. The thing with Pod Kletnoff is, and there's always that time difference. There's the Russian time difference, right? They're 12 hours ahead. Because I worked with that Russian startup this summer, and it's a killer. That's a big 12 hours, you know.
So we'd have to start in the early afternoon or something like, or maybe the morning.
Early morning or late at night. Yeah, with this a little bit of overlap.
Yeah, because like right now in Russia, they're just getting up, right? So. You know,
oh yeah, so maybe we could just keep these things going on late, and whoever wants to stick around.
I think it was 10 hours. I think it was 10 hours. 10 hours ahead.
It could be. It could be. I was working with a company that's a little bit further east, so I think Moscow may be 10.
Oh, okay, yeah.
Right.
Like if he's in Siberia or something, it could be 10 or 12 hours.
Also, we have a companion named Nam Tran, and he is an engineer at Vietnam Airlines, and he works on the side on anti-gravity experiments, and he built many replications. His English isn't very good, so he asked Wayne of Fail Forward Research to do his own, presentations whenever he has something to show, because he doesn't really speak English that well. We're trying to make this a international affair. We want everybody involved. I truly believe that the only way to anti-gravity disclosure is to get rid of the ego, and don't chase after the dollar, chase after the equipment, because right now, in order to bring something that this revolutionary out, it's not possible with just one person. We need a team of people, around the world, all working on it together, and I think it can revolutionize the world. The most exciting thing I think about when I envision, building an anti-gravity craft is not ferrying people to Mars. We'll let Elon try that industry. I think it's mining the asteroid belt. I think if you want to bring on big money and really make a difference on planet Earth, stop open pit mining. Stop mining altogether. There's so much pure elements out in the asteroid belt that we can bring back here and really make life on Earth a lot better very quickly.
Yeah. Well, I think it's on the right track. I mean, and what you're doing right now, what I was trying to do with American Anti-Gravity, what Jeremy is, Jeremy has what, 95? You have 95,000 followers on YouTube. So, it's open, honest inquiry, right? And
Jeremy, really big thanks to him. He's kind of our PR guy, and he's one of the catalysts that made this thing happen, because I hooked up with him when he went on his UFO road trip, and I showed him the lab, and he's connected with so many people that he's the modern Ron Kita. Ron Kita is, for the older folk, he's the modern version of that. And that's how I met Jeremiah and many other people, and Jacob. And that's how I found out about Alzafon, by getting on his show, and somebody posted it in the comments section. So it's very important to fish out the people who are actually passionate about this thing, and get them in the same room, like we're doing right here. You get everyone in the same room, talk about what you're actually doing as you're doing it, and that's the best to bring about the research.
And cross-pollinate. That's the big thing. Cross-pollinate. Yeah. It's just, I think it's not just diversity of ideas, it's diversity of learning, diversity of knowledge, right? Because really every single one of us in one way or another, to some degree, has had to dig through 100, 200 years of bits and pieces at this point. Everybody's got different bits and pieces, so.
Oh, I see Wayne has something to show us. Wayne, are you there?
Yeah, I just been messing around with this for a while here, just trying to. Yeah, yeah. I've just been messing around with this for a while here. Can you hear me? Hello?
We can hear you. You have the floor. Go for it.
Hello? Can you hear me?
Yeah, we can hear you. Just go for it. You have the floor.
Okay. Yeah, I've just been messing around with this. I've had this idea of what happens if you put different materials in a strong magnetic field, and then also apply a high voltage or a strong electric field between it. And so, talking about theories, I mean, it kind of, in my mind, it kind of is something like possibly like dynamic nuclear orientation, but so you got the so the magnetic field helps polarize the orbital electrons, which also help to polarize the nuclei. So here I've got some bismuth powder and some other ferromagnetic powder. I don't know what it is exactly, but I just got a bunch of different chemicals here, and they all have elements that like sodium, so their spin, copper sulfate, just some things I had around here. And then here I've got, and here's vegetable oil, bismuth, and I think it's just bismuth, yeah. So I was messing around with this digital scale. Every time I turned on the high voltage, this would change, but I think it's just the way this interacts with the scale, the load cell in there. So I just put it on this mechanical scale here. So it's, yeah, just if I could see that move. This is a volt multiplier here. It's coming out of this transformer here that Nan gave me. I'm not sure what the output is here. I think it's probably about 10 kilovolts. So that's like, I think that's these stages. If I go any higher, it just arcs over through here. So magnetic field in there is about 2,000 Gauss. So I don't know, probably nothing will happen. I'm just going to turn the power on. And probably you guys can't see anything. I don't want to get my phone too close to that because that's like a lot of high voltage there. Yeah, I don't see anything moving there.
Fail forward research. Tell us about the choice of the name.
Well, I started my YouTube channel. I just started putting videos up about 6 years ago. And at that time, I was kind of dabbling in a number of different things like what you might call free energy. Just trying to make over unity electric generators and that kind of thing. At that time, I had done some experiments with T.T. Brown stuff, charging up. I made some discs that I attached to a TV screen, or not a TV screen, a TV flyback transformer. And I actually saw some movement and stuff like that. And I talked to Jeremiah about it. And he was pretty excited. But I did that like 9 years ago. But then I kind of dabbled with it for a while there, and then I left it for years. But I guess about a year ago, I started, I had a lot of questions around the anti-gravity side of things, and I really wanted to just get to the bottom of it. And I knew that I would have to do a lot of experiments, and because there's so much conflicting information out there online and stuff. So
It really is the holy grail of science and the holy grail of, you know, the whole UFO mystery, that it's just covered in bullshit. There's so much disinformation out there of,
yeah,
you know, dead ends that you can try to discourage people from this. And it's people like you, fail forward research, that every time you fail, it's, yes, I failed. You know, we're going to fail forward.
Yeah.
Newton didn't discover.
Yeah. So
before he discovered a light bulb, he discovered 1,000 ways how not to make a light bulb.
Well, yeah, and I wouldn't,
exactly.
I wouldn't feel negative at all. God knows how many experiments have I built. Bill, you're probably in the same boat, right? How many experiments have all of us built that just didn't do anything at all, you know? I mean, and it could be worse. At least you didn't get a big shock from it. I've had that happen, you know?
I've never had that happen. Yeah.
Give it time. It'll happen.
Oh, shut up.
I've been shocked a few times. One of these put together recently, I got a zap. Yeah, that lit me up. So yeah, I changed the name of my channel, Fail Forward Research. I had this concept of, you know, you just gotta, like in business or whatever, you gotta embrace failure, and you gotta try things, because it's not all figured out. It's not all laid out for you. So I had all these questions around all these experiments I just felt like I need to do around Townsend Brown type of his findings and those patents.
Well, you know, if I could elaborate on that also in terms of experimental stuff. One of the things that makes experiments so important, and I've seen this, like you go to a conference, right? And they'll put like, you know, they put the graphs and they say, okay, well, this or that isn't above the noise. The thing is, there are secrets hiding in the noise. Whenever they do one of these experiments that you read about in the papers, they're testing for one specific thing, but there's all sorts of other stuff that oftentimes they notice or see. Maybe it doesn't make sense, but it might make sense to somebody else. And I've seen that so many times where you're reading through a paper and they'll say, well, we also saw this. Oh, okay. But you know, but that was outside of our experimental parameters. We don't know what was going on. We're not going to deal with it. We don't have money for it. And so Wayne, with what you're doing, you see all of those things, and you're in a frame of mind where you can say, hey, this might matter.
Yeah, I can testify to Wayne seeing that he's replicated a lot of the same experiments that I've done. Not replicated my personal experiments, but more so we both replicated the same older experiments independently of each other. And he's noticed and pointed out phenomena in his observations that I've seen, but never really paid a lot of attention to. And one of those interesting things is you have two charged objects. One is originally a neutral object, and another one is an object that you're adding charge to. Both of these objects are, you know, fairly soft surfaced, so they don't have ionization points. And what ends up happening is if you charge one of the charged objects very quickly so that it acquires a charge, an electric field is built up between itself and the second object. If you then suddenly discharge the charged object, even though the second object received or gave no quantity of electrons other than what it originally started with, so it's still in a system of balance, it appears to experience a simultaneous impulse repulsion force upon the impulse discharge of the charged object. And it's one of those strange phenomena that we both notice, but I've always kind of figured it could be explainable in much simpler terms, but then to investigate it, when we started to look at it and try to intentionally create these effects and amplify them, we noticed other strange phenomena. So Wayne is the first one in the research group to point that out. And I could definitely validate, yeah, you're right about that. He does see the possibilities of these things that most of us ignore.
And it was almost like too difficult to see. Like it was
it's fast. It's an instantaneous event. Like it's there and it's gone. Yeah. It's really hard to observe.
Yeah, but I captured some of it in one of my videos, like in slow motion. I could see that, you know, that lead mass it moved a little more than I thought it should have. So
Yeah, and it's the same thing in the spherical video that we shared too amongst the group, and those things move too. The spheres moved as well. It doesn't
Yeah.
seem to be material specific. It works on paper as well as you verified in an earlier experiment. It works on dielectrics as well as conductors.
Yeah, anything.
Yeah,
So-
I mean, these are all things that, you know, just underline the why this group, what we're doing right here is so important. Just being able to share our observations from the lab directly with other people who are in the lab basically makes the entire planet a lab. So if any of you know anyone else who's actually working on these experiments or couldn't be, you know, cajoled to start experimenting again, I think we could really make a major breakthrough in this field. And I totally disagree with the mainstream view that, you know, anti-gravity is 100 years or 1,000 years away. I think it's past technology that was unique applications of past technology that were just misunderstood. It's those little things that, you know, Wayne observed, or, you know, something that Tesla observed that really point out the most important factors that we all missed. And everyone's, you know, in their own little boat. They're working on the basics, but it's very hard to find an EPR specialist for some reason. And, you know, like I said, that chart of the different electron spins around different atoms, you know, where can I find something like that? Maybe that has really some connection to dynamic nuclear orientation and anti-gravity. I believe this stuff has been covered up. And one of the reasons it was covered up is because it was too simple. It was like an atom bomb that anyone can build. You know, not really an atom bomb, it's a movement device. But getting back to power of attraction, right after I tried that experiment with this vacuum tube, I realized that the tube was only putting out 4 watts. And I was thinking to myself, maybe it's not about the high voltage, maybe it's about the total amount of joules that are being transferred, the total amount of energy going from one point to another that creates this effect. So I was like, okay, what's the most powerful fast tube I can find? And this is what I got off of eBay. It is the CX1538. There's actually papers written on this tube. We got 2 of them. They were like $75 each. This is out of the Berkeley Labs Linear Accelerator, which actually discovered berkelium and americium, elements 97 and 98. So it is a very fast, high voltage, high current tube, capable of 186 megawatt impulses that I plan on trying with the impulse experiment. And as Bill mentioned earlier, it, you know, or made me think it might be interesting to stick magnets on that receiving capacitor and see if the effect is amplified. So, you know, having these conversations really pushes anti-gravity or alternative propulsion forward. And I'm very glad we're here. Jeremiah, do you have anything to show us? He's got an amazing lab.
You know, I set it up earlier, and then I ran the impulse thing, and 160 kV is supposed to be the clipping point on that system. I have it limited to 100 kV, but every so often, a weird ion channel does something strange, and it's an open system right now, so it's not insulated, it's not encased. Well, it's in prototype stage. Anyways, we had a 168 kV arc reach over the system and grab onto the output negative terminal of the power transformer and completely fry its multiplier out. So unfortunately, that system just went down earlier, and that was the experiment that I had set up on the bench, so I won't be showing that. At this moment, I'm unwinding the original primary of that transformer so I can replace it with another one from stock. This is just rather unfortunate, but it is what it is. Experiment.
This is the this is the nature of experimentation. You also have that other device, the one that has like a weird surface effect that can attract objects.
Yeah, I do have that. What I need to do is actually get Zoom on my phone. I'm not set up to do that right now. It turns out I tried to test it earlier, but I got on the call, and it's been a pretty busy night until, and as you already know, I was on another call earlier too. So I will get that set up, and we'll do another conference call, and we'll get some experiments showing so I can demonstrate a few of the weird phenomena that we've seen just for the sheer curiosity and exploration of the participants in the call. And you know, they can take away from it what they will and make their own assumptions about it. But we'll share that. I'm just not set up for it tonight, unfortunately. But yeah, good stuff down the line for sure. We're going to definitely have some good things to share.
Awesome, awesome. Yeah, it's really about the knowledge that we're sharing. That's where the
Yeah, the power is in the people here. This is really where the key is. You have different ideas here, and many of them disagree with each other, but a very wide range of fields and some very brilliant perspectives and different approaches. And you know, it's the places where we can kind of align our efforts and agree on things that we can work together and move forward with some of our efforts. And I think pretty much for the most part, I would say we all kind of share the same goal. I mean, how many of us were promised flying cars, or, you know, dreamed about space colonies, or dreamed about the future and the fantastic place that it would be? But now here we are, you know, in 2020, and we're looking at it, and it's sort of a train wreck. And I think that we all want better for ourselves, for our families, and for our species. And unfortunately, it's not been given to us. And if we consider that, whether conspiracy or not, it's already out there, or it's never been discovered, the fact is that here we have a group that, even if it hasn't been done, maybe together we can actually do it. And that to me is more important than anything.
Amen. Amen to that. Tacon Aerospace asked a question. Tacon, can you unmute your mic?
And I think that's Robert O'Keefe, I believe.
I'm from England, Manchester, so I don't know how you'll get on with my accent.
Well, I can understand you quite well.
Hopefully you guys can hear me.
Yeah. Yeah, we can hear you.
Okay. Now, it's been great listening in so far. Well, really interesting stuff. We're happy to share what we've been doing concerning anti-gravity. We've found that we're looking at the microwave frequencies and the electromagnetic frequencies not as you normally would, but as a way of producing really high out-of-phase audible frequencies. And from experiments we've carried out on some of the stuff we've built, we sort of believe that, trying to keep it simple, there's particles that are flowing through everything, through the atoms to the core of the planet. So gravity itself is a weak force that comes from all the different stars within the universe, and that are attracted to the core of different planets based on the size of what we call a star seed in the core of the planet. So these particles are, say, created in our sun and stream out. They're responsible for the creation of photons. They're pretty much responsible for everything. But one of the things that we found is, as these particles flow through the atomic structure of different materials, they create, one, there's a laminar flow, and then there's interactions where these particles collide with the atomic structure, and which creates photonic bursts of energy, which allows us to see what we're looking at. And then the rest of these particles that pass close by create like an eddy current within the atomic structure. And it's that eddy current which is gravity itself. Now, we tried for about 15 years to shield with, like we built different microwave plasma units, different frequency generators. We messed around with some crazy big electromagnetic field generators. And what we realized was, by creating 7 different frequencies, which are all slightly out of phase of each other, it sets up a harmonic within the material that you're working with. And it's only that harmonic of sound frequencies that allow these particles to be deflected around an object instead of being able to pass through the object and create that, like the eddy currents, the stiction as they flow through the atomic structure.
Are there any other names of current theories that maybe you could mention? Not necessarily academics theories, but even independent theories that you could reference maybe to give more information about how you came to that position?
Not really, no. Just we have a bunch of stuff written up on our website, and
could you link that? Would be helpful.
Yeah, I can drop the. Well, if you just type tachyon aerospace in Google, we're all over the place. And
I think
found you
that's
guys on LinkedIn.
tachyonaerospace.earth, right? And so then this is Robert speaking, I think.
Yeah.
Okay.
Yeah.
Okay. Well, and welcome, sir. Welcome.
Mark, have you measured any objects inside this field to see if there's any weight loss or any spin induced?
Yeah, we've actually got some stuff on video when I dig it out where we've actually got pieces of steel billet floating, where we've got that assembly. I'll drop you a link to a video of a gravity assist drive that we built. That machine weighs in at about 1.5 ton. Yeah, when the machine started up and running and we applied the frequencies to it, you can lift that machine up from one end with your little finger. So there's, but it's what we learned was that the effects of gravity is, like a gentleman was saying earlier, is greater nearer to the planet, and then as you move away from the planet, it becomes like a weak constant, and different planets have different gravitational effects. And we believe that when a star goes supernova, we believe that the core of the star is solid and it's being fed from a black hole. So we don't believe you can fly into a black hole. We think that the gravitational effect of the core of a star is so immense that it creates this vortex out into another part of the universe and sucks everything in, compresses it into the core, and then the sun is a result of this compression, but also a result of this compression of these particles that stream out into the infinite of the universe from every star. And as they collide with the atomic structure of matter itself, photons are created. So like photons don't travel through the infinite of space, they're being created all the time. So as an example, where you're sat now, everything between what you see in the room and yourself is in darkness. It's the interaction of these particles that are flowing through, say, the table, that every time one of these particles hits the atomic structure of the wood, that wood has got a particular, its atomic structure has got a particular note, a particular frequency, and every time one of these particles strike that, what happens is it's like there's a burst of electromagnetic energy created, which is the photon which you see, and also the particles that don't hit the atomic structure flow through, because everything's 99.9 something empty space anyway, so these particles flow through all this, and the ones that are passed close by the atomic structure is what gravity actually is. So if you take a lump of lead and you take a lump of styrofoam or aluminium, if you was to remove all the empty space, you're not really left with much. So when you, it's hard to explain. It's just that what we've been doing is we've been looking at microwaves and producing plasmas and frequencies, and a combination of 7 frequencies together, it's always 7 frequencies. But when you combine these frequencies and you resonate the material, then what happens is these particles can no longer pass through. They have to flow around. It's like it shields it from this flow of energy.
Yeah,
Okay,
and that,
I have a couple questions. Sorry, you can go ahead first, Tim.
sorry. Well, what you're describing almost sounds like neutrinos, but it's also when you describe 7 frequencies, I think that's a natural harmonic resonance, right? Isn't that a 7 frequency order?
It's sort of natural harmonics, but you have to knock them out of phase. Like we created well, how do I put this? We manipulated a magnetic field in neodymium magnets and knocked them out of phase. So we were able to take the 2 north poles or the 2 south poles, and when you push them together, they obviously don't want to stick.
One thing I want to point out is that anytime you're combining more than one frequency, you're actually creating beat frequencies. 1 or 2 or more frequencies, you're creating beat frequencies, which are very much indicative of squeezed coherent states, that you're having squeezed coherent states. Look up if you look up squeezed states and coherent states, and you can see what a squeezed coherent state is in quantum mechanics, and it looks literally like a waveform with beat frequencies. And those are literally, quite literally, what is generated. Now, with regards to the particles that you're talking about, why did you feel the need to create a whole new particle? Why couldn't this just be an inherent property of the photon or the light itself? Where does this extra particle come from?
Well, we sort of believe that if you look at the universe itself and you look at you take a star, for instance, we've always believed that the core of stars is solid, and we published this years and years ago, before NASA and SOHO decided and changed their mind that the sun wasn't just a big gas ball and that it could theoretically have a solid core. But we've always sort of understood that the core was solid, and our take is that for the gravity side, this was our reasoning, was that when a star goes supernova and explodes, it's not just all the gas that goes off out into space. The core becomes supercritical and becomes that dense. The gravity that it's creating becomes like unimaginable. But basically when it explodes, the core fractures and breaks up, and whole pieces of this core fly out into the infinite of space. And each one of these cores has enough gravity in it to start pulling, and whole clumps of it all spin off into the infinite of the universe. But they also pull all the gas and all the material together again. So each one of these clumps start pulling gas and matter to itself and creates a new planet over maybe billions of years. But the planets are all formed around these, what we call a star seed, which is a piece of an existing star that has blown up. And the bigger pieces are powerful enough, gravitationally powerful enough, to open up a new wormhole or a new black hole to suck in from another part of the universe matter to become more and more condensed, and it reaches a critical point then where it literally starts producing like the hydrogen and everything, so just basically to become a star again. So a new star's born that way. But when that happens, this new star then streams off these particles, which then pass and travel back to the star seed. So they're being emitted away from the star. So the core of the Earth has a star seed. Mars, Jupiter, all the different planets, they all have a seed at the core, which attract these particles back. And that's what we believe is the interaction of gravity. So when we've shielded things, you have to shield it in a special way. It's not just about creating several harmonics on a piece of material. What we've done is we take the magnets which we worked on creating bipolar jets. So our magnets, we can have the two south poles stick together.
Yeah, I wanted to ask you on the engineering side specifically, because you mentioned that earlier, and I've been thinking about it ever since you first said it. How is it that you're actually controlling or modulating these very high strength magnets?
Like what we've done is we've had to build like our own technology to develop technology, because it's not off the shelf. Like you guys are all familiar with that. This isn't stuff you can go in Radio
Oh
Shack.
yeah, right. We want to basically know how it would be constructed so we can attempt to either do a replication or at least learn about it.
Yeah, what we did, it's like if you look at the basics of the magnet, how the electrons line up, what we did was we built a piece of equipment which consisted of AC and DC coils in a cylinder, and we applied different frequencies into the coils using a combination of like crystal resonators based on quartz.
What kind of range were the frequencies in, if you don't mind me asking? Because just to get to the sort of technical details, like what kind of power and what range of frequencies were you guys running with?
Well, at the time, we run the apparatus off the equivalent of about 10 kilowatts of power.
10 kilowatts or 10 kilovolts, you said?
No, 10 kilowatts.
10 kilowatts, that's a lot of power, wow.
And what I'll do, like when you guys are on next as well, I'll drop some papers on with all the information, and you can play with it, because you might be able to improve on it.
That would be incredibly helpful and very welcome.
So to answer your question anyway, so what we did with the magnets, and this was, I actually spoke in Sharjah in the Middle East, outside of Dubai, at a physics conference on this one particular technology that we did, and it was published in like a peer-reviewed publication, but a closed-door publication. Every year there's a few hundred scientists and physicists get together, and we go to different parts of the world and hold a big conference. So the resulting publications like a telephone book of everybody's work, but it's only given out to the people in the conversation, in the conference. And I've represented the Ukraine for a number of years at these conferences, and spoke about like the technology that we developed. So on the magnet side, what we've done is basically destabilized the magnetic field in a series of resonating magnetic fields, where we focus the magnetic frequency into the magnet in the middle of the cylinder. So we put the magnet in the cylinder, and it floats within a DC field in the middle, and then we have a series of AC, DC, AC coils around either.
Floats, by floats, do you mean it magnetically it's magnetically coupled and sort of rests in a magnetic approximation, or do you mean it physically, mechanically is levitating in the center of this thing?
Yeah, it levitates in the middle. It's being held there by the electromagnetic field. So what we do is we play these several frequencies into the magnet, and we keep turning the amplitude up. And what happens is the magnet just drops out the field, and when it drops out the field, it's done. It just falls to the bottom of the cylinder onto the lab bench. Now, when we take two of these magnets, you've got north-north repel, south-south repel, north-south stick, which is normal. But what happens with these magnets, if you push, say, the two south poles or the two north poles together, they fight like they don't want to stick,
Right.
and then all of a sudden they suddenly pulse and stick. Now, when they stick, you end up with a south pole, say at either end, or a north pole on the outside, with your south pole in the middle, which
Now,
creates.
what kind of a configuration is this that you put these magnets in where you can push them together like this? Is this a solenoid, that just a single coil solenoid of some sort, or is there a coil
No,
configuration?
just by hand. No, just by hand. You can set the magnets literally by hand and take the two south poles.
You just mean mechanically force them together, the bodies of the magnets themselves.
It's yeah. What happens is it's like we don't want to stick, so you like trying to push them, and it's like we don't want to go, and then all of a sudden you feel the magnet pulse and they jump and stick together. I have got a picture of iron filings.
Let me grab some magnets. I've got 2 magnets. I got to try that.
So what happens is, though, that you end up with jets coming out of both ends of the magnet. So you have like North Pole jets or South Pole jets. Now, what you do then is you make, like you can either use microwave electromagnetics or you can use static. There's all different sorts of ways you can generate the frequencies, but the idea is to then generate the frequency in the coils around. You put a coil around these magnets where the two north poles are stuck together, and you apply these frequencies into the coil, and what happens is the magnet starts to try and separate and reconnect. So when it does that, what it's doing, it's flipping the electrons in the atomic structure of the magnet. So it's sort of like, let me escape, let me stick, let me escape, let me, then it starts to resonate. Now that the magnets then start creating a harmonic signal, and as they start to separate and connect, they start creating a secondary field in the copper winding that you're putting your audible signal in, because you've now got a movement of north-south poles flipping, almost like not solid state, because there's a resonance there in the connection, but as they oscillate, they're creating a flipping of the poles in the coil, and it sets up like this harmonic. Now that harmonic is transmitted through both of the north poles on either end of the magnet. Now, when you set up several magnets like that and you aim that frequency at a particular material, then that material then resonates with a combination of the several harmonics, but you're focusing the harmonics into particular areas of the material. It's almost a bit like when you aim a laser at, say, a piece of wood, you're focusing energy at one point where the wood will burn and the rest of the wood's unaffected. So by setting these frequency generators up around the material, you're able to create areas of different resonant frequencies within the material. And when you do that, it seems to shield the material from this flow of outside. We don't know what the particles are, we haven't got a name for them, but it shields from these particles. And when you do that, the effect is like not complete anti-gravity, but you can definitely, with like the machine video, I'll try and share it with the group, but I think it's on our website anyway. But with the gravity assist, it actually reduces the weight, so you can literally pick 1.5 ton up from one end of this machine and lift the machine up. You can even put wheels on this particular piece of technology, like small wheels, and you could put one of the things we did, we put several 25 kilo bags of cement on one end, And when you move the machine forwards, it floats up in the air at the other end, and it will also lift the weight of the cement with it.
Yeah, I'm looking in the chat, and unfortunately, we don't see the video. But I'd really love to see that. I did go on your website and browse briefly. I couldn't find the link to that video, but I'd love it.
I'll see if I can drop it on the group now with everyone, because I was, yeah. I'll see if I can do it now. Just bear with me one sec. I hope this works. Yeah, I think that's right. There you go.
So your name is Brian, right?
No, Robert.
Robert. Okay. I'm sorry. I'm pretty bad with names.
Yeah, me too.
I'm Mark. So.
Okay. Yeah, I'm not a physicist. It's just that I've spent my whole life. I'm like 56 now. I've spent my whole life as an innovator, and I've built things that fly, engines, new propulsion systems, and Tachyon Aerospace has been around in a group form, a bit like you guys are doing with gravitics and everything. We've been around for about 10 years. Prior to that, I've spent 36 years with all this sort of research. I've married a Ukrainian woman, so I lived out in the Ukraine, and then ended up representing the Ministerium of the Ukraine in a whole bunch of physics conferences around the world. So, and then like with the aerospace company, we've actually solved a lot of interesting things. But like I was listening to what you guys were saying before, we've had, like we're connected with like the Commander-in-Chief of Space Force and Space Command and the scientists there, and like all the aerospace companies, but they're all, and we've been to conferences around the world and spoke at aerospace conferences with NASA and everyone, and it's they're all, like you guys are saying, but all doing it for the wrong reasons.
Right. So why do you think we don't actually have these craft nowadays? What's the hindrance, in your opinion?
I think ultimately it's like innovation comes down to the ability to think out of the box. That's all it is. And the problem is, it's like you guys are all genius because it's like you think you're not blinkered. The problem is, if you take an engineer, like we have people that work with us, and any day we would take someone before they go to university and before they study their engineering degrees, because when they do that, they literally end up focused. It's like they're taught to think a particular way and not to look at things outside of that spectrum.
I totally agree with you on that. And I actually had an argument before with Jeremy about it. I think science is a bit of a cult, and they have their methodology. And if you think outside the box, you're spanked and given an F. And I'm kind of I'm proud of the fact that I've never, graduated college. I've never technically even graduated high school. Just spent my entire life researching the Bible, and learned everything that I learned autodidactically. And I know many people in this field that are like that. And usually the out of the box thinkers are the ones that, haven't gone through that, that mindset that puts you in the box and you can't think out of it.
Yeah, because it's like, we were at one aerospace conference in particular. We were in Macedonia, and NASA was there, and I think Airbus and a few others were there. And one of our team asked the NASA guy, I think his name was Bill, and said, why is it when you've got companies and engineers and people like ourselves that have got this radically advanced technology that's built that people can see working and touch and see, why is it that it's really difficult to put this into the industry? And NASA turned around and said that if you're 12 months ahead of your time with what you're researching and what you're doing, the rest of the industry considers you crazy. And it's like, we, as I say, we were at one aerospace conference in particular. We were in Macedonia, and NASA was there, and if you're 6 months ahead of your time, you're also considered crazy.
I'm
If
dealing with that exact situation, and I'm getting divorced, and she's using that against me. But I totally understand what you're saying. Anyone who is open enough to think of anti-gravity in this sense of buying a klystron and, you know, actually trying this stuff, they're considered crazy. And so was Galileo, and so was Einstein, and so was everybody who've ever thought out of the box, you know, ahead into the future. They've always considered them crazy. So I think it's a good sign.
Yeah, no, it's like we use off the Apple thing as to the crazy ones, the rebels, the misfits. That speech, we have that on our website and on our LinkedIn. It's like our whole team sort of operate that way. We don't conform to rules, and we just do what we do the way we do it. But it's our experience has been that we looked at thinking gravity was to do with magnets. We thought gravity was to do with like microwaves. We built a number, I think was maybe pictures of small plasma reactors and generators that we've built, and they all operate, they all do the job. Like our engines have 2 of these reactors on either end of our engines for particular reasons. But what we realized was that and also it ties in with the Bible as well in some ways, because we sort of realized that anything that you need to move, anything that you need to like create anti-gravity or to create an effect of anti-gravity can't be done with a magnet. It can't be done with a microwave, but it can, but the understanding is that the frequency is an audible frequency, and the combination of these 7 frequencies together shield the object, which then allows you to be able to easily move or lift the object. Like the object has still got, and when you understand that these objects are mostly empty space anyway, if you was to take like a 20-ton stone slab of granite, if you remove all the empty space, you're left with something the size of a pea. Now, the particles that flow through that, most of them that would have most of them that would have flowed through that slab when it was big would have created a greater like eddy current and a greater laminar flow through the bigger space, the bigger volume of empty space than it does when it's been condensed to the size of a pea. So
I have a quick question about this before I'm about to head to bed, but I'm intrigued by the 7 waveforms that you add together to generate the single waveform that you need to use to create this. And I was wondering the shape of that waveform. You know, like when I think of adding up different frequencies, I think of like a Fourier series kind of expansion where each one of these 7 things is a different term on the Fourier series. And I just kind of think of like when you start adding up different frequencies, you end up getting a different shape of a wave, you know. So I was wondering if this shape of the waveform, is it closer to like a square wave, a sawtooth?
It's almost like a quasi sort of, because you're coming at the material from different directions and focused different frequencies from different directions. The frequencies that you generate, they're unique to the particular form of acceleration. So if you're using a tuned quartz crystal with an electromagnetic field which is being generated from the oscillating magnet in the coil, that field is unique in its own right, and it doesn't, you can't plug an oscilloscope in or anything and look at the signal, because when you plug like an oscilloscope in, or even if you put a transducer onto the steel block to look at it, it's just noise. It doesn't, it's like out of phase. The noise that's being created, the harmonics, it just comes back as noise and not as a signal. It doesn't show you a sawtooth or a square wave or anything. But if you move your transducer around the material, depending on which magnetic jet and the way you've got it configured around the particular sample piece, different parts of it resonate at different frequencies at all times. So it's a bit like, maybe you could look at it like having a guitar and you play different notes as you move your finger down the string. The block is a combination of different frequencies at different parts of the material. But when you put these several frequencies together, then it shields these particles passing through, which then reduces the weight of the object. And the microwave stuff that you're doing works. That creates the frequencies, the magnetics, the electromagnetics. We've been playing with this for 35 years, and where we're at now with it is the understanding that we've come to. There may be other ways. That it's not just what we're doing is the answer, but we've had results where we've got these machines to operate. The video that I dropped, the Google Drive video, this machine operates on them principles. And we've had that machine running the best part of 10 kVA, 24 hours a day. We can configure it. It's part of our flight system, but we can configure this machine to gyroscopically change the way the energy pulses through it in a helix, so we can manipulate the gyroscopic flow. And when we do that, this whole machine just literally, there'll always be one part of the machine on the floor. Don't get me wrong, there's one bit on the floor, but it will lift up. So if we slow down a particular set of drums in the configuration, then the whole machine will tilt up, say, at 45 degrees to the left. But what's interesting is you can put several 25 kilo bags of cement on the back end of the machine, and it will lift its own weight and the weight of the cement like it's not even there.
But it's still pushing against the ground effectively, so it does have a counterpoise, and whatever weight it lifts on one side, regardless of its leverage advantage, even though it's gyroscopically attenuated, it basically can only lift as much as it can push down on the opposite side. Is that correct?
Yeah, but if you put a set of scales on the other side, you know, like the big industrial ones that you stick a pallet on.
Yeah, this is the important part. Go on.
Yeah, and you lift it, it doesn't see the cement, it only sees the machine.
Now that is particularly strange.
Now that's the bit that we got excited about, because this whole machine is operating on these principles.
Wouldn't that mean, though, if it didn't see the cement, I mean, the cement is sort of an arbitrary weight in terms of the total mass, right? So you could have put a lot more cement or a lot less cement on there, but if it didn't see the cement at all, as if it didn't register that lifting force at all when it did its action, I mean, wouldn't that mean effectively you could put an infinite amount of weight there and it would still respond the same way and never low down the scale?
Well, we've to be honest, we only ever tried it with several bags of cement. That's all we had.
But that's still, I mean, we're talking, what, a few hundred pounds, perhaps?
Yeah, 25 kilos a bag
Yeah,
in
so
England.
that's significant. I just wonder what the upper limits of that experiment are, and yeah, I would love to see a paper or data, video, or just anything of that experiment at all. I would love to review that information and just take a look at it so I can see a little bit more about how it was done and hopefully gain something to take away from it.
Well, on the video, on the group chat, I've dropped a link to a video of the machine running.
I did see the video of the machine. It just shows the array spinning with each of the individual pieces, but it doesn't really show what it's capable of doing or lifting, as far as I was able to see. So I'm just wondering if you have any other materials other than just.
Yeah, no, we have more stuff that I'll dig out and share. Yeah, the way that machine operates is because of the frequencies. What we're doing is we're constantly removing the weight from one side of this machine, and in doing that, it rotates. So it's how do you explain? Do you know when I was saying about the the bipolar fields and the frequency, what we actually do is we take the weight away from one side of each one of the drums by changing the harmonics. Like you'll hear when the machine's running, it's got a weird sort of, apart from the unfortunate clacking that was, the chassis wasn't quite balanced.
Like on these drums, are there electrical connections or are there mechanical vibration systems or piezoelectric transducers? I mean, how are these cylinders connected to the frame and how are they receiving whatever harmonic they're receiving? I was confused by the setup because it doesn't really show any of the operating parameters. It just sort of shows these things spinning on this machine. So could you explain a little more?
Yeah, what we've got, we have a central shaft with the arms coming off the shaft, and then on the end of each set of two arms, we have another fixed drive shaft that has a hole going into it, and then the actual drums are fixed on a bearing at each end, so the drum's free to just spin on the shaft. And then each one of the drums weighs within the region of about 60 kilos each. And inside the drum, on the shaft, which doesn't move, is our bipolar field generator array, which is sending the different harmonic frequencies into the drum itself on one side.
And I guess that's really the heart of the question then, because if I'm understanding correctly, just to kind of backtrack before you get too far in the description. So I understand. So this machine has a central shaft. The central shaft rotates the entire assembly of rods that hold the individual drums. The drums themselves, if I'm understanding correctly again, are independently suspended from each shaft. They have no mechanical torque connection to that shaft other than their ability to be freely rotated. So otherwise they don't receive any power or have a connection. Each of the drums contains an independent system of this field generator. And that system operates without external power inputs from the machine or any other connections. Is that all correct? Am I understanding?
We put into the actual machine, we put 20 volts of power in. If you look at the machine on one end, we've got this bit of a bodged up set of brass strips as a slip ring that we bodged together.
Okay, so each of the drums then receives 20 volts from this slip ring.
Well, 20 volts, 80 watts across the whole of the 8 drums.
Are they in series, parallel, that kind of thing?
No, we're all individual. We've got the power supply going in, so we got the 20 volts at about 80 watts of solar power that we used on it.
Oh, that's
going
cool.
in, and then that's fed into each of the drums along the wiring through the hole in the end of the fixed shaft that the drums are allowed to rotate on, and then that powers up the field generator. And then what that's doing is one side of the drum is constantly lost weight and the other side becomes heavy, so the drum constantly rotates. Now the drums will typically rotate at about 3,500 RPM. Now the video doesn't do it justice because of the frame rate refresh on the video camera, but effectively we've got 8 60 kilo gyros spinning at 3,500 RPM, set up in a helical form on a shaft, which then it transmits the gyroscopic energy from the outside spinning drums via lever action to the central shaft, which then generates like several ton of torque on the end of the drive shaft.
So the drive shaft, is that actually spun at all mechanically, or is the spinning of the drive shaft a result of the motion of the drums?
The drive shaft's only a result of the motion of the drums around in orbit.
Okay, thank you. That really helps clarify too. That helps quite a bit actually. And I guess the other big question would be the secret of what's inside the drums with these field generators. I mean, are these mechanical gyroscopic systems, or do they have some kind of electrical field component?
The solid state, to a degree, the just the bipolar magnets, which are set up inside coils, that we create a set of frequencies that get played into each one of the coils,
Yeah, we
And
would
then the
love to see a
magnets,
diagram of the magnet assembly because we'd love to, independently replicate and validate your work if that's a possibility.
yeah, no, we're happy to share this. It's not a problem.
That's fantastic.
Yeah, so what you have to remember is, well, this is probably a dumb thing to say, but Nidium magnets are pretty powerful in their own right, so you don't need to create any sort of energy. You don't need to increase energy to make them any stronger. So if you've got an N52 magnet that's, say, 20 mil diameter by 60 mil long, then that's a pretty significant neodymium magnet, N52. It's a real powerful magnet. Now you take two of them and you reprogram the atomic structure of them so the electrons can flip, so you can stick the two. I'll see if I can drop a picture to the group so you can see the.
That would be really helpful because honestly, I've looked up some of the information that you've said so far and just tried to Google it, and I've had a heck of a time finding anything.
Yeah, a lot of this stuff's secret. This isn't.
Anything you could share, though, pretty much we're counting on you to share whatever you can so we can try to validate this stuff. That would be fantastic because it seems like you really hold the key here in terms of what you've worked on. You're the guy to go to for the info. So anything you can provide would be excellent, and we would really appreciate it.
Do you know, right, I've just clicked on Summit now on this, and it's done it to me again. Right, how do you get, because I've never, right, what I've got now is like a film strip with everyone's video on and names, but the whole screen's
It's at the top right corner, it says View. You click on that, you'll see a little thing that goes between speaker and gallery, and you also have the option of full screen. Corner of your video window, that is. Top right?
I'm on a MacBook.
Yeah,
and
same here.
all I've got at the minute, I've got Finder, Files, Edit, View, Go, Window, and Help on the top.
Oh, you're looking at the top left. Yeah, are you trying to get back out of this the panel view where you see all the names?
Yeah, because now I'm on like a film strip. That's what happens.
You want to be you're looking at the Zoom meeting window, not your bar on the top. And in the Zoom meeting window, you're going to just see at the top corner there's like this little 9-gridded square thing that says View. If you click on that, you can change your view.
Okay, I'll just click on the link again and pull out.
Robert, also, if you have a camera, you can turn on your camera so we can see you.
Yeah, okay.
Tim, can you send Robert a link to open his camera?
I think this might work. I'm launching the meeting again.
I'm falling asleep, guys. I've been up since early. It was great meeting you all, and I'm headed off to bed. Thanks.
Good night, Jeremy.
Hey, good night, guys.
Good night.
Tim, can you send Robert a prompt to start his video? You click on
yes.
you could click on that the 3 dots there.
There you go.
And he'll get a prompt for it.
Right, let me. Right, start my video.
Yeah.
Right, I'm gonna have a piece of tape over the camera.
Oh, yeah, don't we all?
Okay.
Hello. Welcome to APEC.
Hey guys, yeah, it's a bit later. I think we're at nearly 5 in the morning.
Oh wow! Thanks for staying up so late.
Yeah, no, it's all. I'm used to it because a lot of our team members are out in the US.
Hey, any chance that for perhaps later, since you haven't got the links up and running right now, we could send email back and forth so we can take a look at some of that information and try to replicate?
Yeah.
That's the way for you to get that over.
Has my camera come on for everybody or just?
I think we can all see it.
Yeah, we can all.
Yeah, but I don't know why it's done this. I mean, as soon as I went off the screen to find the.
There's the real possibility that your computer is compromised or your software is hacked or malfunctioning. That's something we've seen a lot in this field.
I know we've got that pretty well covered. It's just something I've done stupid. We've been up against the NSA and everyone.
Oh, rather.
So
I've had major connections this whole conference, but it's probably just my RAM running out.
Matt, I sent you the picture of magnets. Is that something that you can share with the rest of the group on the private chat? I think when I was trying to send it, because you was talking, I clicked on you.
So that was Mark you're talking to there? Mark, you sent Mark some pictures?
Oh, I think he sent to you.
Because I haven't gotten any pictures at all from you so far. Unfortunately, I'm looking in the chat here, and it's just not showing anything like that.
In the chat group, just right, there's a drop down where you click everyone.
I'm pretty sure it's showing that already.
This might work now.
Yeah, it's showing the whole chat here, and I haven't gotten anything from him yet.
Right, so now that didn't go to the whole group, did it?
We got it to me privately.
Right, okay, so that. Okay, so I need to change it to whole group. Everyone, right, I got it. Right, I should be able to do it again now.
I'm gonna download it and try to send it to everyone if that doesn't work. Oh yeah, you got it. Send it to everyone now.
Yeah.
Okay, there it is. There is the file. Excellent. Let's take a look at that.
Yeah, this is an old picture. 2008.
The idea of modifying the different frames between this two sides of this cylinder, to me, is a phenomenal idea. And however it's being done harmonically or what, I mean, that's a pretty phenomenal claim and definitely something that we should be looking into. And if we'd known about it earlier, would have been.
Well, it's all, the thing is, everything that you're doing with the microwaves and the magnetics, it's all correct. It's just that because we did all that, and it's like you're absolutely spot on with it. But what we realised, and it's like there may be two different effects with gravity, I don't know, but what we realised was we looked at them as we started to look at it as an audible signal and to convert it into an audible signal so we can put a combination of several signals together to create that gravity effect. But on that picture, it shows the only way we figured we could demonstrate what was going on with the magnets was to basically put them under some paper and sprinkle iron filings over it, because you can't fake that. So it shows on the left, it shows a normal magnetic field, and then on the right, it shows the two south poles with the north poles in the middle. And then it's like, they'd been nice with a bigger sheet of paper really, but you can see like if you imagine this in 3D, it almost shows.
Right now.
So if you imagine that in 3D, it shows you've got a disc that emanates out from the center from the north.
Yeah, I know what you're talking about. It's almost like it's like the magnetic fields are the accretion disk of a black hole, and the rotation.
Yeah, or the bipolar, like pulsar.
I've got two N48 neodymiums, 22 millimeters diameter here, and 5 millimeters thick, and I press two of them together, but at no point, no matter how well they're aligned with north to north or south to south, they don't seem to have any moment at which their repulsion weakens or there is any point of attraction. So how do we achieve that?
You've got to reprogram them. And
I mean, how do you actually, I understand the heating and the inflow current to reprogram them, but what ways, what patterns do you reprogram them with, I guess would be the good question.
What I'll do when we're all next on, because a lot of what I do have is all on my hard drive, so don't keep it on the laptop.
Smart, very smart, yeah.
Yeah, because now I promise you won't believe the trouble we've had.
I will believe you, because we've had quite a bit ourselves. I really do believe you.
Over the years.
Oh yeah, you name it, I've probably seen worse.
It's like, we've even got police records. We've been kidnapped, been held under house arrest by the Syrians, been shot at.
I've had 2 laboratories shut down, been accused of all sorts of manner of things. We know.
They're even getting involved in my divorce. It's like, it's insane. And they were outside the shop over here hitting us with radiation, and I felt it. That's why I have so many Geiger counters. And the email shit, oh my God, it's just like nonstop. They're threatening everyone. But at the end of the day, they're not coming to my face and saying, you're going to get hurt by this. And I'm seeing a lot of like just support, you know, things are appearing that I need. Wayne found that piece of equipment just lying on the side of the street that he needed. And there's a lot of good going on as well. But the bad has definitely happened. And I think there was a turning point. This is getting into a little bit of a conspiracy theory, but I don't know if you're familiar with the ATIP article from the New York Times on December 16th, 2017, when the New York Times, which is a very conservative newspaper, posted that the Pentagon's been investigating flying saucers and yada, yada, yada. And, you know, it's a real phenomenon. It was started by Harry Reid with $22 million. And the head of that program, which is Lou Elizondo, who was actually invited to this chat, he got on national news and said, yeah, those things are real and they're extraterrestrial. So I think after that period, the mentality of the secret keepers has changed, and there's been a lot less, you know, open attacks against people. You could tell me, Robert, you could tell me if that's true, but has anything happened to you guys since 2018?
Like we're really good friends with Tracy Rydner. You know, from the movie Apollo 13, Tom Hanks, Tracy, right? We're good friends with them. Now, Tracy Rydner, the whole of Tracy Rydner's family is Lawrence Livermore Labs.
All right.
And also, you know, the Montauk Project, the jump room.
No, I'm not familiar with them, but did they have any experience after 2018, after that event?
Well, let's just say that Tracy Rydner's family are the people behind all that, why we get the hassle.
Okay.
Let's just say that. If you look up Tracy Rydner, Apollo 13, she was like Tom Hanks' wife in the movie, but if you look them up, basically, her family's Lawrence Livermore. And they're involved in a lot of stuff, but I can absolutely believe that I've got memories of being subject to what may have been some sort of energy attack weapons in the past, where it's impossible to sleep and irritable but to be honest with you, the last 35 years have just been crazy anyway. It's been really interesting.
Okay, so I just made up the iron powder. I actually have 2 very large neodymium magnets that are pushed together in opposition, which is, I'm assuming, what you had in that experiment, in that picture that you sent.
Well, he was saying that they were reprogrammed magnets specifically. That's what we were just talking about.
But not
magnets.
Yeah,
I'll show you what regular magnets look like so we can just compare.
Yeah. What needs to do is one of the days I'll actually try and work out a way of demonstrating this on video where you can see where I can put the magnet down and push another magnet towards it, so you can see it push the other one away.
There's actually an easy way to do that, Tachyon. Super easy way. All you got to do is take a neodymium magnet, stick a fairly thick steel washer on the end of it, or for that matter, any ferromagnetic material on the end of it, and in its far field, it'll repel another, like pole, but if you get it close enough, they'll mutually attract the iron and repolarize that, since it has a saturation point high enough to hold both fields. So there is another way to do that. I wonder what the field symmetry would be compared to 2 south poles or 2 north poles stuck against a washer, where there's this mutual interaction within that material itself versus the reprogramming of the magnets themselves. What do you think?
Yeah, that might be a good way to try it.
Because I have a feeling that as far as the pattern looks on the iron filings, it would generate a very similar pattern. It doesn't mean the magnets would work the same way or work with your machine, but I do believe the pattern would look the same on the filings.
Yeah,
Like,
what you need to do, you need to take the iron filings off the paper, put your magnet underneath the big sheet of paper, and then sprinkle the iron filings down with.
I was just wondering what kind of sprinkling device I have. Maybe like a
your fingertips, Mark. Your fingers.
Your fingers. Just.
I don't like that. No, because
put it in a pepper shaker then.
I'll put it in a pepper shaker. Just give me a second.
But yeah.
That's funny. I think that's funny. I thought about that too. There's a Steinmetz reference about actually taking a very strong changing magnetic field and dropping onto it some dielectric ground mica powder, because in the time of Steinmetz, mica was the leading insulator, fantastic, but pitiful by today's standards dielectric material. And if you sprinkle these filings onto this changing magnetic field because it's dielectric, it would be moved around by the field and form concentric rings around the field poles instead of lines between them. And I thought that was a really, really interesting experiment. I have yet to replicate it, but just the idea that it's in that book, it's an old published book. I think it'll be really cool to demonstrate that, since I haven't seen it done yet.
I'll tell you what, it'd be nice to actually see this magnetic field with ferrous fluid.
That would be cool too. I remember, I can't remember this guy's name. I think his first name was David. He talks about a series of different magnetic configurations, mainly like curved magnets or banana-shaped magnets. Just the term banana-shaped magnet, you probably find his name. But regardless of who he is, he talks about this device that, would scan and map a magnetic field and map all of its poles and where they were, and show you in a three-dimensional computer graph. Sort of if you were to use like a slice-away CNC where we just cut layers and take pictures. This device sort of did that profiling with the magnetic field and would scan through it. And he found some interesting geometries with these opposing poles as well, which leads me back into what you may have discovered.
Well, one of the things we tried, do you remember when we come out with the Halibat array? The magnetic Halibat array, where we configure a series of magnets in a disk.
The Hallback array is a really fantastic way to project a field with a very high intensity at the surface, but what it gains in intensity at that point, it loses in range, and unfortunately even the Hallback array suffers from a problem where, in terms of the magnetic material used, you don't actually get the entire field of all that material. You get a percentage of it, but it's much stronger at that concentration point.
What we tried to do, because the back of that array doesn't have any energy potentially, it's just like
it's supposed to be null.
And we tried building a couple of them and putting them together similar to our magnetic assembly to see if we could get the same effects, but it doesn't give the same effect because it doesn't generate the disk through the middle.
Okay.
Because if you look at that photo, you'll see like the normal magnetic field where the field sweeps round in the lines. And then you look at the south-south one, you can see the two norths in the middle and the south and south. And then you can see the way the field comes out and back in.
Yeah, I do see the, it's like two little toroidal fields sort of, and you have this barrier like ring, almost like a ring around it that you can see this concentration zone.
Yeah, and then it's like, I wish I'd have had more filings on it really, but it's one of them things when you innovate and you've like solved what you were trying to do, you don't sort of bother with it anymore. You just sort of know, right, that's what we're going to work with now. But we do still have all the paperwork and all the information, so be able to share that for you to have a look, and maybe you could improve on it. Or
yeah, and if you do, we can replicate it. We can share it with you and show you what we did, and maybe that will give you validity. You can say, well, this independent laboratory also did it, and this is what they found, and it agrees with these results. So, I mean, we could help each other out, definitely, and we would learn something along the way, which is honestly the most important part to us, because we're just trying to understand how this all works.
Yeah, no, that's what it comes down to. But if you look at that picture with the south-south, and then you imagine a coil around the middle of that, and then you play a frequency into that coil, what it does, it destabilizes the magnetic coupling, And when it does that, the poles start to flip really fast. And as they flip, you've now got a pole flipping from north, south in the middle inside a coil, which then induces an electrical charge in the coil, like moving magnetic field in a coil. So it induces a charge in the coil. And then what happens is it creates almost like a feedback resonance. And then it's the actual jets that, like, we don't bother with the discs coming out around the middle, because when you've put the coil on there, that's pretty much shielded. What we focus on is the jet coming out the top and bottom. So then we position that jet towards the piece of material. So say like you was like going to manipulate that glasses case, you would have the jet set so they're positioned, several of them around this case, and then when you're playing the different harmonics into that field, into the coils, and then there's an out of phase harmonic that gets played back into the electrical charge in the coil, that's of the frequency of the charge that's being fed in. That changes the whole sort of dynamics of the frequency. So the jets then resonate that frequency. So they then focus that into the material. So then this material becomes a combination of several like different harmonics.
So then the question is, are these coils independently driven with each one frequency, and it's the frequencies of all the independent resonators that combine in the material, or is each coil literally driven with 7 different frequencies?
7 different frequencies.
I'm
Each
guessing.
coil.
So the coil only has 2 input wires. That means that basically these 7 frequency generators, they're somehow combined, or there's some way that you interface all 7 frequencies so that you can just feed 2 wires with an amplifier. Is that correct?
Yeah, we have like an input, positive, negative input straight in. This is going to be fun.
Oh, that's looking pretty cool. Can you guys see
You might
it?
have to do it. You might have to do it from higher up though.
Let me try to get the. I think the
'Cause
problem
you've got
is
some
the
pretty
problem is
hefty.
that my shirt is black, so you can't see it.
Just you've got some pretty hefty magnets there.
Oh, these are very hefty magnets. Okay, so there we go. That's a great setup. I'll try that.
Yeah, so we have the input. So you've got several frequency generators that are generating the frequencies, and they're all fed then, amplified and fed into a single coil around each array of like 2 magnets. And then when we resonate them magnets, it allows them to separate and connect. And then because what's happening is the poles are flipping, like the electrons flip in their orientation in the magnetic field. So they resonate, and as they resonate, and you end up with a moving magnetic field, but in sort of a solid state form inside the coil. And that induces a charge, like in the coil, an electrical charge in the coil, which then changes the harmonics of the frequency that's going in. And that harmonics comes out as a magnetic resonance in the beam.
Can you guys still?
Wow, it's a really complicated thing, I understand, to explain, and hopefully not too complicated to do, but
No, it's not complicated to do. It's like pretty much what you've just done there, but you're having to bolt the magnets together. It's like, imagine that you can just push them together wherever you don't want to go, and then all of a sudden they stick. Because what's important is that they're allowed to come undone and stick again. And what's interesting, the more that you separate them and put them back together, the easier it gets. And after about 10 or 15 times, it's like there's no magnetic field there at all. There's nothing. The magnets have like gone dead. It's really strange. And then you turn the magnet round, turn one of them round, and put the north to the south, whichever way, or south to the north, and they stick. Separate it again, turn it round. We don't want to stick again.
Hey, Mark, if you separate those, you drop the filings on. What we're looking for is this idea of a disk showing up in the center, where instead of the filings just sort of being around one pole and then the other, there's this seeming line between the two poles that sort of collects. Did you see that?
What I saw was there was this strange area. There's like this blink spot in this around the magnets, and out there is some sort of field out here, but it's very strange that there's this no-go zone for the iron filings. But I was not seeing a line shooting out like he showed earlier.
The poles may be a little too far away as well. I mean, still, they may actually have to be, physically pressed up against each other and touching, perhaps.
Do they have to be?
The two magnets, you want the two magnets. See, you're sort of doing it with brute force, where we've done it where we've reprogrammed to the stick. You're literally bolting the two north or the two souths and forcing them together, but you want them touching.
Oh, okay. I could tighten it up and actually get them touching. By the way, the material, this is an aluminum rod with brass bolts, so it's non-ferromagnetic materials. So
Yeah, but when you compress the magnetic field like that, you may be getting some sort of diamagnetics going on in the aluminum.
It's possible.
But nothing that I wouldn't think it's going to hurt with what you're trying to do on the display.
Right, and you just got to find what you can use.
But it should be okay. I'd just tighten them up so they're touching, and then put your iron filings on a piece of paper and sprinkle them from high up and just let them like rain down on it.
Yeah, that's what I did over here with the glass. I could try it with a piece of paper. It'd probably give you better viewing capabilities. One sec. Try that again. So you're saying sticking the two magnets together tighter would make a different effect?
Yeah, if you put, because it's like the way ours are working though, it's like they're programmed to do that, where you don't want to stick and then we suddenly stick. What you're doing there is literally physically trying to force two south or two north poles together. You're literally forcing them together.
Yeah, that's what this is. All right.
Yeah, so it'll be interesting to see the effect you get, but maybe if you put the magnet on the table, put the piece of glass over the magnet, then put your paper on top, your white paper, and then sprinkle the filings down from about 2 foot away and just let them fall down.
I wouldn't use glass. The glass felt like it was about to break. I'd probably use some other material.
You can always just leave the piece of paper over the top, because that's all we did. We just put
this magnet is very, very strong, and I don't want the iron filings getting stuck to it.
Right. No, it can be fun. It's,
one second. I'll find something that will work with. MDF.
Yes, so back to this apparatus and this setup. So there you go, that'll do it. So the other nice thing about this is imagine we've done this in the lab. You take a block of aluminium and you heat it up over a Bunsen burner, and you put a crystal-based transducer on it and phase lock loop. And what you can do is you can record the frequency of the heat. So heat's just a frequency of movement of like molecules. So what you do is you can record that frequency, and then by using the bipolar field generators, like this effect is demonstrating in the picture, you can transmit the beam to a corresponding magnet array, and then that corresponding magnet array is connected to the transducer back to a block of aluminium, and the second block of aluminium will heat up on the same frequency. But you can't transmit that signal of the frequency of the heat with a radio signal or with a normal electromagnetic field like radio signal. You have to transmit it on the beam that's generated by the the magnetic field generator. So it allows you to literally heat one cube up on one side of the lab, and then aim the magnet across to the other corresponding magnets on the other side of the room. And that field then transmits along the beam the frequency, and then the other magnet resonates at that frequency inside the coil.
I thought I wanted to know what you were talking about before, but man, I really want the information on this experiment. We want to do this one. This is so fundamental. The idea of transmitting thermal energy from one location to another is such an incredible idea. And as far as something to test, if we could test it,
we've done that.
Test it.
We've done this and sort of proved it, tested it, and published it in this publication, but it was based around on our flight system, like obviously on a single stage to orbit and beyond sort of craft. You need to be able to move heat around on the craft. So we've used this technique on our smart skin to move heat to other parts of the craft.
Wow, I mean,
So
we
constantly
gotta get
move
more
heat,
info.
but it's what's interesting. We tried to, because what the thinking was, if you think of it in layman terms, if you've got a block, let's say you've got a block of aluminium, and you heat this block up with a Bunsen burner, then that is a particular frequency for heat, generates movement in other molecules, or that becomes a frequency. So what you do is you make a crystal transducer, quartz transducer, and you record the frequency of that heat. Now, if you try and transmit that on, say, an FM 20 watt transmitter, because we built some little 20 watt FM transmitters like you can use on the radio, and try to transmit that signal and then play that, but you can't. The frequency which is being generated when this block of aluminium has been heated up with the Bunsen burner, the FM transmitter can't transmit enough of an amplitude or transmit.
Yeah, I was just about to say, it's an amplitude limitation, right? Because there's actual information, physical energy in terms of joules per centimeter that's being radiated from that thing in a radiated field. But to try to just create the same types of signal peaks without the same exact amplitude levels would be effectively just playing back, you know, a tape recording of a live band. It's a totally different thing, and it might be acoustically where you're sitting the same thing, but it's certainly not the entirety of the acoustics that are going on there.
But by playing that signal into the coil that sits around and amplifying it and playing it into the coil that sits around the bipolar magnetic assembly, then both ends of that magnet are giving out a jet of, say, a north or south pole, which way you configure it. It doesn't, not really relative, but it gives out a jet. So what you do is you then have that picture that you see there of the two south poles with your coil. You aim the jet across the room to line it up with the corresponding other set of magnets. And what it does is that then makes the other set of magnets resonate in the corresponding coil, and then the coil, it produces an electrical charge in the coil, and then that electrical charge is unique to the signal that has just come from the other magnet, and that's played, then the jet of the magnet is aimed into the aluminium, the block, and it causes a resonance, and the other piece of aluminium heats up the same as the one that you've just transmitted from.
That's fascinating. Now, you have a system of two coils and two blocks of aluminium. You input a signal into coil A. Do you also simultaneously input an amplified signal into coil B? And
no, that one doesn't need power in the
that
coil
one
A.
is passive then. It receives the signal only. It doesn't have any power source.
Yeah, the other one just receives the frequency because the frequency is carried on the jet, on the beam, and then the other magnet starts to resonate inside the coil. So when it resonates in the coil, it produces an electrical, produces a voltage at a particular frequency in the coil, and then that voltage then interacts with the oscillating magnetic field, which creates a copycat of the original signal.
So then naturally I have to ask, what's the range on this thing?
Well, we only done it over about 40 feet, so I don't know.
Did you say 40 feet?
Yeah, that was all, because like that was how long the lab was.
40 feet is ridiculous. How big were these magnets?
About 20, is it 25 B, 12 mil, 25 mil B.
I mean, okay, honestly, that's a tiny little neodymium magnet compared to what's available today. That thing is tiny, and you're talking about a distance, an effective field range for any signal transmitted, which is drastically orders of magnitude beyond any capability of electromagnetism, as you were talking about. It's not electromagnetic, but I mean, that a 40 feet range on something that small would indicate, yeah, a totally different type of field that we don't even have a name for, probably.
Well, it's just that the beam coming out, it's the focused beam coming out of the magnet, because when you've got your coil around the magnet, what you do, not what you do, what's happening is the connection between the two, which like both north poles, end up switching and becoming like flip-flopping, like say north-south, so they end up resonating like this.
So instead of the field poles wrapping up on each other like they normally close right away, right? Boyd Bushman released a patent called the magnetic field beamer, or magnetic beamer. Yeah, just magnetic beamer. And it effectively was an array of at least 3 magnets, preferably 5 or more magnets, where all except for one magnet were arranged axially with all the poles pointing in towards the center of a shaft and all the poles pointing out straight away from the center. No physical thing in the center. And then on one side of that space, the same distance as these other periphery axial magnets were from the center of their location, was another magnet with its like pole pointed towards it. And a coil positioned directly around that last magnet, that single one in the center, was flipped around with high amplitudes. And this would break the field lines that couple between all the outside magnets and the center magnet and cause a beam to be produced, which Bushman himself claimed could extend the discharge length of a Van de Graaff generator or Tesla coil from being only a centimeter to several centimeters or several inches. And it had other strange phenomena, but it had the ability to beam the magnetic signal straight out the end of this thing as a result of disrupting the magnetic coupling between these different poles. And it sounds kind of like what you're talking about is very similar. It disrupts.
Yeah, well, if you look at this from the point of view where your magnets, and you look at that field, and then you've got a DC coil around that in the middle, and you're playing this frequency into the DC coil, what happens is the magnet starts to separate and attach, but at a phenomenal rate, at like thousands and thousands of hertz. So they're resonating, and then when they start the poles are flip-flopping, then you end up with moving poles inside the coil, which then generates another electric field in the coil that's around it. So you've got a DC field now, which let's just say it resonates at 10 hertz. And then you then causing the magnets on the inside of the coil to flip-flop. So you've now got the poles are flip-flopping at the junction.
So, Robert, let me interrupt for just a second. I noticed we have another guest, Monomorphic, down there. I want to ask if they would like to introduce themselves, or if they have anything to add or anything like that. I just noticed they were down there.
I've been wondering the same thing too. I didn't want to ask. I figured some people just want to kind of listen in, but
I think
know that though. I would.
It could. I think it might be Bill Alex. I think it might be Bill Alex's wife, or she might have left her, because I think she came on. I think that person came on at the same time Bill Alex did. So I think she may have left her Zoom just on and gone to bed. But at this time of the night, it would be difficult to blame her.
We've been going for a while, but it's been a pretty interesting one all in all. Just a general, I would say it's, again, a nice kind of more relaxed discussion.
Yeah. Well, and I think that's good, right? I mean, I don't think anybody has any, you know,
Well, I mean, if we're on tonight, right, it's because we have allocated the time to pursue the passions that, you know, things we care about on this topic, because it's such a seldom pursued and such a seldom discussed thing. Just the idea of even having a human conversation with other people who give a darn about the implications of the technology, for me, is significant, at least. And I would imagine that people who joined tonight probably had somewhat of a similar idea, because a lot of people stuck around for a while, which is kind of neat, because, you know, some of these are big names in here. But
And some of them only left because their batteries died.
yeah, yeah. I mean, people can't stay on forever, but they stuck around for about as long as they could. And I think in general, just there's that discussion that shows you're not alone in this topic. And generally speaking, we've been alone for a really long time.
Well, yeah. I mean, that's one of the challenges. I've mentioned this to Mark earlier in chat. That the problem is everybody. Well, and again, you guys, I believe, maybe I'm mistaken, but you guys are a little younger than me, right? So Robert probably knows when you're digging through textbooks and digging through card catalogs, and you know, back in the day, we didn't have the internet, right? So it was like,
I did the same thing though before the net, man. I was at my local library and I drove down, you know, I had somebody drive me down to the, you know, big Milwaukee library, where it's just a huge place and they had all kinds of books. I found books on, you know, military secret projects and other conspiracy stuff that claimed about advanced propulsion research. And honestly, I mean, for all I read and for all I found, and as many things as I checked out and returned, and the few that I didn't return, they got lost. Yeah, I mean, there was just really not a lot of good engineerable information, and it left me as a youngster questioning both the validity of people's ability to report information accurately and the academic community for literally not addressing any of these claims. So I'm between this place where people make amazing claims but don't tell you at all how to do it, and this place where people say all these amazing claims are totally impossible but also tell you don't tell you how to disprove it. So here I am stuck somewhere in the middle, and I'm like, the only way to find out, honestly, is to test it.
Well, here, I'm going to boot Monomorphic, because I think that is Bill's. I'm pretty sure that's Bill's wife. So let me boot her out. That way it doesn't run all night in there. Okay.
Yeah, so I wanted to talk a little bit about business. And by business, I mean APEC. Robert, we're planning on calling this meeting, this get together, APEC, or Alternative Propulsion Engineering Conference, or more of a discussion, but APEC has a nice ring to it. And then this way we could have a logo and, you know, make it a little bit more official, and, you know, put out invitations that look a little bit more enticing than just a Zoom link.
How many people do you want on your conference calls? Do you want to keep it a small group, or do you want?
This is only our second one, and so far this has been the most we've had. So you've already seen the greatest number of people in here so far today.
Yeah,
we can post it if you want, advertise it on our website and post it on LinkedIn, because we did a web thing and we ended up with a few thousand people on it.
Well,
for anything like that.
Yeah. So
private engineering group.
I guess my thought. Sorry,
Go ahead.
Funny. I'm sitting cross-legged in my chair.
Me and Tim were having conversations about this on a side chat. My fear is that there's a lot of kooks in this industry, and we don't want flat earthers. We want people with engineerable ideas. So if you have a far out wormhole idea, you know, keep it to the wormhole conference.
Well, we'll listen to it if you tell us how to build it, but we just want.
Yes. Yeah,
we'll listen to anything that can be built.
Yeah. So we're underscoring the word engineering. This is Alternative Propulsion Engineering Conference. We're not interested in the theory unless it has an engineerable, you know, solution. So we really need to weed out the people who have these crazy ideas that they love, and that they're, you know, they put their ego to the idea, and that it just throws everyone else off. So what I was thinking of doing is maybe having, you know, an open conversation as tryouts to the actual conference, so we could weed out who's actually viable and who's not.
Yeah. That's a good idea, because
you know, what might help, I think what might help also is for the next, you know, maybe we could try and do one of these every week or something like that, and maybe just invite different folks. you guys probably all know Paul Murad, right? Because I've been promoting him on my site for years. And
Oh,
then
I
Ron,
know he's here, wasn't he?
I'll meet
yeah,
him.
Paul was here. Paul was here. And then Ron Kita, and I'm glad
that
Paul
guy.
was here because he's been ill lately. So I'm glad he's feeling
Paul
better.
and Ron were amazing. I mean, Ron is
Yeah.
just a freaking encyclopedia.
Yeah, you know,
I'll tell you what. I'll tell
Ron
you
was
what.
old when I got into this. So, you know, but then John Hutchison, actually, John Hutchison just texted me and he said that he had too many people around. It was going to be chaos. So he didn't want to join. And then, you know, there are lots of other folks too. And again, what I would do is let me put a post up on American Anti-Gravity and I can add some other, I can forward that to a couple of friends, you know, so.
You
Yeah.
see the power of this conference, hey, Tim?
Yeah, well, you know, to be honest, I mean, again, it's not that the technology is there, it's that everybody knows how to use Zoom now, right? Like I've been wanting to get these folks together for 20 years. And the problem is, it's like, well, I don't know how to set this up. I don't know how to do this. I don't know how to do that. And it just became this nightmare. And now it's like, oh, wow, you can do group video conferences. And the pandemic has forced everybody to learn Zoom. So now you can actually get people like Ron Kita on a video call, right?
That's a crazy idea, right?
Yeah. And so I think, I think that really is kind of historic because all of these, like with these old timers, the old timers all met each other at conferences. They used to go to conferences and meet each other, but not all at once, you know?
And they never had their equipment with them. Like over here, you can go live from my lab. Jeremiah and Payne both have their own lab and they're showing you actual experiments that they're working on. And one of the main problems in this field I find is that you might have some interesting idea about some experiment that was done a couple of years ago, why they did it wrong. It's irrelevant already. By the time you see that and, you know, talk to the guy, he's already, you know, reused those parts. He's already thrown out the setup. So your input becomes irrelevant. Right now, when we're showing you an actual experiment going on, input's very relevant. I actually had one of the, there was a lady that was watching the entire time and she says she's a waveguide expert and I'm definitely going to hook up with her.
You know, yeah. And I have weird, but part of this is me. I mean, I don't know, I'm 44, but I feel kind of old. and, you know, I've interviewed when I counted, well, this is okay. Just the audio interviews on American Anti-Gravity, 85 audio interviews. And then in terms of videos, conference interviews, probably another 60, 50, 60, something like that. And one of the things that I've been having, one of the reasons that I'm writing again, you know, just in general, is a lot of the older folks that I've been interviewing have been passing away. And in those interviews that I've done, I have a couple that were absolutely brilliant who's just no longer with us. Ari de Geis, he passed. I interviewed Robert Boussard, he passed. Now, that wasn't all gravity, right? They're different specializations, but I would say probably 10% or more of the folks that I've interviewed have passed. And so, you know, one of the things that I'm really thinking about now with this stuff is legacy, right? Because one of the things that the old timers always, their approach was like, take this, pass it on, you know, because they don't want to, with those guys, they don't want to lose. For a lot of them, that was their life's work. Or if it wasn't their life,
what we want to do. We are here with open arms saying, please tell us how you did what you did so that we can do it too and validate you and also show the world that it's real.
Yeah. Well, and I think that's where things are going, you know?
It really, it seems like it, because I think the momentum is behind it and just the audience tonight. You know, a lot of people that you wouldn't expect on here. Again, Ron, for fine example, Richard Benderick last time. I mean, holy cow with that guy.
Yeah. So
you wouldn't expect.
And one of the things that I'd like to do, and this is one of the things I've noticed, right? And so you guys haven't met Robert O'Keefe before, right? And so this is, but the thing is, what you all have is you all have an interest and you're all looking stuff up. And so you put it like Jeremy's YouTube channel, American Anti-Gravity, stuff like that. The advantage to that then is somebody can go in there and they'll build familiarity with it, even if they don't know you. And then it's not, you know, right? And that's not just Mark, that's Robert, that's Paul, that's anybody. They start to build familiarity, and that's the standing on the shoulders of giants, right? Where everybody is learning, and we're all kind of helping bring each other up, I guess, you know.
Exactly. We've got a new YouTube channel that we're working on now, and
Yeah.
we haven't uploaded any videos to it yet, but it's going to basically be an amalgamation of experiments and open discussion about the experimental process of what we intend to do to try to verify many of these claims out there and give them some validity.
Yeah, there you go. Well, and I'm working on AAG right now, actually. So that's one of my projects. I've got a lot of cleanup work to do, but
and Jeremy Rye is on the same boat. He's also rebuilding alien scientist, and he's been working on trying to create a new media outlet to fix the old image problems with the associations and the names. So there's a lot going on. I think we're all kind of rebranding and starting something new. I'm going from sort of Join the Technicians, which is a do-it-yourself high voltage and experimentation channel, which doesn't have a lot of videos really, but has a fairly high reception rate, to something brand new here. And that's really my passion where it sits. So I think the Propulsion channel.
I'm happy to be able to put some of this stuff up. I'd seriously considered taking American Anti-Gravity down earlier this year. You know, I mean, I did all that work, but then at the same time, in my case, I noticed a couple of things. Number one, like pretty much everything I had done has been liberated, right, in one way or another. And that's our community. You know, people take stuff and repost it. And so all the videos I've done have been moved to other channels, and all of the stuff I've written has been moved to other, you know, and that's not bad, actually. I'm proud that I had enough value to do that. But so part of it was that, but then the traffic was down also. So I'm like, well, so this gives it new purpose. I'd love to put up a few of these, you know? And so what I talked to Mark about was just maybe cutting these up, right? You know, and just cut.
Right, because each speaker sort of has their own very, very valuable piece of information, and then there's some discussion parsed throughout. But if it could be all put into a single block where, you know, questions asked to that particular participant are relevant to how other people can do it, it'll be really helpful.
Yeah, and
a lot of work and editing, but yeah, I mean, it's possible.
I'll have to figure out what the best way to. We'll probably have to go night by night and maybe outline some of the speakers or something like that. Try and outline some of the topics.
Yeah, just give like one speaker, you know, X amount of minutes or whatever to explain this thing. And then there's going to be another speaker after that. This way we can keep the topics separated.
Yeah.
And make the editing much easier and make it a more coherent conversations that we're not just going off in different directions all the time.
And as you get to know these people better, you'll get to know more what to ask too. Like Bill Alec, for instance. So Bill Alec, he's been more kind of into the free energy side of things, but he's an electronics engineer. That's been his career, and he's been building like sensors. He built an Accutron watch. He was trying to measure time anomalies and stuff like that. So
I was talking about writing. We actually hooked up with a writer who has a degree from Harvard, who took interest in the Falcon Space project, and she's been writing a book about us. I have it over here, one of the early drafts. It's actually like 7 or 8 chapters in already. It's written as a nonfiction, a creative nonfiction, she calls it. And yeah, if we ever come across anything revolutionary, there's going to be a book ready to be published that, you know, for the general masses to understand, you know, how this happened and how it came about, and bring more interest to the topic. What we're working on ultimately will revolutionize the world, and you know, nobody should take that lightly. You all realize the implications of discovering real anti-gravity, and it's not to be understated. So it's something that should be taken seriously, and it cannot happen privately. It cannot happen secretly. It needs to happen in the open. And everyone needs to have access to it in order to create this bloom of new technology and new transportation methods.
Yeah, the other thing is just safety in numbers.
I'm sorry, what did you say?
Oh, he said there's safety in numbers.
Oh, yes, there is safety in numbers. And,
absolutely.
We try to shout it as loud as I want. And I was joking the other night. Tim was telling me, oh, be careful. China's going to come and hack you to try to get your information. And I said, all they have to do is sign up to my YouTube channel. Yeah, freaking sign up to my YouTube channel. You'll get everything.
The thing is though, getting a group of people to collaborate, it's like we're all specialized at what we do, but we can't all do what each other do. It's like what you're working on with the microwave stuff. It's like I understand a bit, but I could never dream of being at that level of your understanding what you're working at. So each one of us,
it won't happen. You got to dream that you can do it, and then you can do it.
but it's like you can only focus on so much. Like you can only. I'm not talking about the blinker approach. I'm on about each one of everybody that was on here tonight has their own speciality and their own understanding of what they're trying to do. So I think like with Tachyon Aerospace sharing some of what we've done with anti-gravity effects, and like I know what we've done's been validated as well. We've had it validated by third-party government agencies that have looked at our technology and done reports.
But have you ever had it replicated?
Yeah, we've replicated a number of
Have you had it
machines.
independently replicated, I guess is what I'm asking. An independent lab replicate your experiment.
Yeah,
Okay,
we've had a couple.
Robert, are you on Ron Kita's email list?
Probably.
You'll notice lots of extra commas and periods. Then you know you're on his list.
Yeah, because one of the guys, I know one of them's really super opinionated and not afraid to speak his mind. I don't know whether that's wrong, but I know there's. I was introduced to. I'd have to go back and look because it's like we speak to a lot of people in Tachyon, but I know one of the guys was talking to in the US. He was the physicist working on anti-gravity, and he was working on alternative forms of energy. So we were telling him what we'd done and shared some of the stuff we'd done. And he said, I need to put you on this list with all these guys that are working on it. So that's how I ended up on this list now. Because there's quite a lot of people on there. There's maybe 50 odd people, is it? I know there's a lot.
Yeah, there's quite a few people on that list. I actually mixed a couple of lists together. Estes Park this year, which is the whatever propulsion workshop, was canceled in person, and instead they did a Zoom conference. And at that point, I realized that, hey,
Yeah, you did mix lists together. Let me take a look here.
Yeah, I did. There's like 100 emails in there. A couple.
You don't even know who you emailed. That's the interesting thing. Let me see.
I really don't. But I do know that Lou Elizondo was on there. So, anyways, I realized that the entire conference, since it was on Zoom, all the conference is a email list at this point. So just copy the email list and voila, send out a Zoom notification and see who shows up. And so far the conversations have been very lively, and we've learned a lot. There's a lot of stuff here that we can take back to the lab. Anyone who was on the chat, who was on the video call, will get a copy of the link. I'm going to post this video up to YouTube unpublished later, and we'll take a vote amongst everyone that was actually here. If anyone doesn't want to show their face, we can cut those parts out. But Tim and others are very interested in posting little snippets of this conference. Robert, how do you feel about that?
Yeah, I'm good. I don't mind.
Okay, so we'll definitely cut your piece out and stick it on. Well,
I'm gonna probably bail out, guys. It's just about time. Mark, do you want to give me a call? Give me a call before you go to bed or something. So, okay, gentlemen, I'm gonna bail out. Robert, it was wonderful being on the call with you. We're gonna try and do this regularly, and what I will try and do is, like, again, cut this up and put pieces up, earlier pieces, because Mark's looking pretty darn tired. But I'll try and get you guys talking. Because I'm excited. It feels like this is kind of, maybe it sounds lame to say it, but it feels like this is historic for this community.
It
and
is.
if we're able to do a few more of these and get a few more people, what I'm excited about is the cross-pollination. I mean, in a weird way, it's a small community, but it's a community that never comes together, right? And so it's all friend of a friend.
And now it's the first time almost ever that we're really coming together in this way. It's exactly as powerful as you think it is. My mind has been thoroughly blown so many times from the sheer amazement of the names in the same space at the same time. And those discussions and the depth they go, I mean, all I can say is humbling and mind-blowing.
Yeah. So gentlemen, have a nice evening, and you know, we'll figure out when the next one happens.
Okay, good night, everyone.
Nice talking.
Night.
Thanks.